Jupiter.
Jupiter.
Jupiter the
That's a
cat?
good name.
Very
In opposition,
friendly
fantastic.
kitty of the two. Mars is a sort of the same age male as Jupiter. We got them sort of together, but he clearly was not bonded well with his mother early on. So he's kind of a feral cat within the house. What are you so loud about right now for?
Robert, I don't know if I've met you before. It's a pleasure to meet you.
You too. Name is familiar.
That's flattering. I know quite a bit of people that have Explore Scientific know me. I'm not sure about the wider audience or the wider astronomical community. I'm sure, I was very flattered when I went to the Florida Star Party, the Winter Star Party back in 2014, and met some people, and they actually recognized me and that I'd written a book. So that kind of surprised me because my book had only been out for about a year or so.
Yeah. Well, Star Hopping came out in '94, and then Cambridge reissued it again in hardback and paperback at the same year, which Simon said they rarely, if ever, do. It has sold over 15,000 copies now.
Oh, that's
They've
great.
been after me for years to do a second edition. I've got a copy all marked up and redlined and such, ready to go.
Oh, yeah.
It's just finding the time to do it because I've been so busy with Luna Cognita. And that's been out only, 18 months or so since, just as we went into shutdown. It came out the day our city went into shutdown. But it has sold over 2,000 copies.
Oh, that's great.
Hardback and over 100 ebooks. So a lot of libraries have already been buying ebook copies. And it has about 80 reviews on Amazon, although, like I said in the other day, Amazon, for some stupid reason, keeps sending out volume 1 to one person, volume 2 to somebody else, volume 3. And so I've got about 10 one-star reviews because of that, and Amazon refuses to take those down, even though their own rules say you're not supposed to write a one-star review because of Amazon screw-up, not because of the quality of the product. So otherwise, I'm pleasantly surprised at how it's done.
That's excellent.
Can I get a mic check? Anyone hear me out there?
Yeah,
I can hear you just fine, Jason.
Hey, Jason.
Hello,
Give you
everyone.
a mic check or a David check or a Karim check
Alice check or
and a David check.
Wendy check
Wendy check.
or just a blank check. That would be.
Blank check would be good. I was gonna say to Jason, no, Jason, I can't hear you.
If you send a blank check, he will.
Let's not tease him, Jerry.
Okay, yeah, that would have been
He's
been
trying to
rude,
make
I guess.
He's connected.
I don't know. It was so long ago when David and I met. Probably one of his talks. I remember the one you gave in Santa Clara was interesting because you played music when you first started your talk, which I thought was really interesting because I would be giving talks for our local group, but I never thought of doing that, playing music beforehand.
Thank you.
Maybe we met in '94 at Lowell. When
we did. In fact, I think I remember you from there.
When we had, my book had just come out and Cambridge had me come out there to sign the books. And what's his name? Westfall, I forget his first name, Dr. Westfall, not
John.
David, different Westfall, had written his book about, who was it? I think it was about Galileo. I forget now his book, but he had started a list of the history of astronomers online, and So he was in the booth with me because he had a Cambridge book too. But that was when we were at Cambridge. I also had listened to a talk by Vera Rubin, in which she told about how when she was trying to take a physics class, I forget which school she went to back east, and when the professor saw that there was a woman in the class, he walked out.
What?
Yeah, because we were talking about women having difficulty with the colleges back in the 40s and 50s or so, and I didn't get a chance to chime in before the subject got changed. But she's the one who saved the Plato, Plato comparative plates and the comparator that Tumba Lowell was about to throw that stuff out. And she said, oh, that stuff's too historical. You got to keep it. So now it's on, as far as I know, last time I was there, it was on display in the Saturn building. Is it still there, David? David Eicher?
It was in the Smithsonian Institution for many years and has just, a few months ago, gone back to Lowell, the blink comparator.
Yeah, the machine and the plates. The
Well,
plates are on display.
The comparator and the A plate for many years were in the Smithsonian, and you could see them in the Air and Space Museum, believe it or not. But they've all, and the B plate was
Hi,
in the stack at
Adrian.
Lowell. And
Hello.
about half a dozen times
Good
I saw
buddy
Brian
Dave.
Skiff fearlessly pull the glass plate out without dropping it, but
Yeah.
the B plate. But now they're all back together at Lowell.
Lowell was closed. They were clearing out the basement, and there were going to be like thousands of plates and books that they were going to sell or give away. And they sold a whole bunch of Lowell's original books, first edition books of all of his Mars books. They were stored in boxes down in the basement, and they were going to get rid of all that too.
That doesn't sound right, Bob. I don't think so. But when did that happen?
This was in the 90s. This was back in 94. They were clearing out the basement for some reason at the Saturn building. And Vera got them to save at least the Pluto plates. I assume the other plates got saved too, but
yeah, everything is there. Yeah. Let me ask Jeff Hall about that. That doesn't sound credible to me.
Yeah, well, it was in
Actually,
94.
Bob, I think one of the Pluto Discovery plates is still at Lowell. The other one is in the Smithsonian Institution.
That's what Eicher just told us.
Yeah.
David, the comparator and the 8 plate just went back a few months ago to Lowell. They're all back at Lowell together now to be displayed. But for many years, the 8 plate and the comparator were in the Smithsonian Air and Space Museum.
Yeah, naturally, they're back there now after I visited in 2018 and they weren't there.
The B plate has
Sorry to hear
always
that,
been there.
Jeff.
If you make friends with Brian Skiff, he'll take you down into the plate stack and pull the B plate out, that has Clyde's handwritten notation on the sleeve. And I've seen that happen 6 or 8 times in the last 40 years. And, if he drops it, that's the end of everything, So it's a fearless thing to pull a glass plate like that out of a plate stack. But that's how you can see the B plate, at least, is befriending Brian Skiff.
Yeah, I got to spend a night under the stars with Brian while he was doing a run of a whole bunch of stars. He had a metal plate attached to the eyepiece on one of the telescopes, and he would rotate that so the light meter would pick up the stars. He was searching for something. Now it's been almost 30 years ago, and I spent a week in their library looking up a lot of the early stuff that I wound up in the book. And right outside the library was Gene and Carolyn Shoemaker's office, right by the copy machine. But they weren't there at that time. They were off hunting craters, I guess, or something. Because I had met Gene the year before at that astronomy conference in 94. I was there for a week in 95. And He's the one that turned me on to Ewan Whitaker, who was a real big help. But one thing about that astronomy conference, he was going to do a talk on Surveyor, and he couldn't find a slide of Surveyor, but he finally found a lantern slide. And then he had to hunt through closets to find a lantern slide projector. That's government work, you know.
David, is my audio okay?
It's
Yeah, we
good.
can hear
Yeah,
you.
we can hear you.
Okay.
Yes.
Hear you just fine.
You all right over there, Bob?
I had 2 strokes last October, and I have
Oh, my
trouble
goodness.
sometimes swallowing. Not that I have a disease or anything. It's just
Well,
been that way since the last stroke. I've the palate and tongue don't communicate well with the little flap that closes the trachea, and stuff goes
My-
down the wrong tube.
yeah, my mom had the same issue. She's still with us too. So
Yeah.
had 2 strokes. Just good to still be alive after you endure those.
Well, in 2014, I spent 3 weeks in the hospital with a stroke and was
Yeah.
totally paralyzed on my left side, and I'm left-handed. So
That's-
I'm very weak, especially with my legs for walking. I used to walk so fast, my wife would always have trouble catching up with me. We were at Great America a week or so ago with the kids, and I had to keep trying to catch up with her,
yeah.
the kids, because I just can't walk very fast anymore.
Well,
So
I
it's a
think
real
at that point, you play for the walking at all being the win.
Yeah,
It's being here is always better than the alternative.
absolutely.
That's I got tested recently. I've been in a couple of events, and though I'm fully vaccinated, I know that there's a chance that you can still catch and spread COVID. So after feeling under the weather, I felt this was the responsible thing to do. Some dry coughing and some sinus symptoms, but I was also fairly dehydrated. Turns out I was negative, and I got the results same
Good
day.
for you, Adrian.
Yep.
Proud
So
of you.
I will keep doing what I'm doing. I have my masks in place, and just continue to be careful with navigation.
When it comes to finding planets outside our solar system, no space mission to date can beat NASA's Kepler. In 5 years, it has found more than 1,000 confirmed exoplanets, with thousands more awaiting confirmation. Kepler finds exoplanets by carefully watching starlight, looking for slight dips in brightness as a planet passes in front of or transits its star. This technique, called time series transit photometry, is most effective for large planets in close orbits. This both maximizes the light loss during a given transit and the number of transits we observe. But how far can astronomers go with this technique? Can we find a twin of Earth? Or even identify whether a planet has moons? With 2 transit photometry missions on the horizon, NASA's TESS and ESA's Plato, some astronomers have examined the limits of this technique with surprising results.
For our study, Michael Hipke and I combined the knowledge or the lesson learned from Kepler with what we know about the future missions like TESS and Plato. And we ask ourselves the question, what would we be able to see if we put these observatories outside our solar system and observe our solar system? And the results are that we probably won't be able to see Mars or Mercury, but everything else in our solar system, we definitely get a solid detection of Earth, solid detection of Venus, also of the outer planets. We might even be able to see ring structures like the one around Saturn and maybe even moons, Jupiter's moons.
In another study, they pushed Kepler to the limit by cleverly combining almost all extrasolar planet data collected by the telescope using an understanding of orbital mechanics.
For example, Jupiter has so-called Trojan asteroids that collect in two specific areas on its orbit, pretty symmetrically to its orbit. And in the study that we did on the Kepler data, where we added up all the phase curves of all 4,000 planets in the Kepler data set, we were even able to see signatures of asteroids in extrasolar systems. And with the future missions, we might even be able to find that in individual systems and not just by putting all the data together. We wanted to figure out what the ultimate limit is that we can do photometry with, and it turns out with the next generation of instruments, we are already hitting the technical limit and are mostly limited by the variation of the host stars themselves, by the huge noise that's coming from the host stars.
The way to push down this noise is by observing stars for longer periods to improve models of the star's behavior, allowing astronomers to tease out the smallest transits. The work of Hipke and Angerhausen shows that future missions will be able to detect Earth-sized planets orbiting Sun-like stars at distances that would allow liquid water. These systems will become prime targets for more detailed study using other missions, such as NASA's James Webb Space Telescope. Will we find a copy of our solar system? How common are habitable worlds, and particularly twins of Earth? The thousands of exoplanets to be discovered by Tess and Plato will go a long way to providing answers.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and welcome to the 59th Global Star Party. It is our theme is the ring planets, and like most of our themes, you know, since the whole universe is interconnected, this could take us almost anywhere. But we have a great lineup of speakers for you tonight, as we always try to do, and I think we always do. So, but tonight we've got Robert Garfinkle, who's an astronomer, author of several astronomy books. Of course, David Levy, David Eicher, Cameron Gillis, Adrian Bradley, Chuck Allen, Jason Guenzel, The Vast Reaches, Jerry Hubble, myself, and we have more coming up later in the program with Cesar, Maxi, and Nico from Argentina, and I believe a couple of, I must be missing somebody here. I need to look at my list, but anyhow, and Chuck Allen from the Astronomical League will also be giving a special presentation later on in the program. And we never know who might enter in the after party, so that's always a little bit of a surprise. But I will start, as we always start, with my hero, my friend, David Levy. David's poetic introductions to the Global Star Party have been a mainstay, and they are. It really is a signature part of our online effort to gather together astronomers and stargazers and lovers of the sky from all over the world to sit down with us each week and participate in Global Star Party. David, I'm going to turn it over to you, man.
Well, thank you, Scott. And it is really a pleasure to be here. Before I begin, I must congratulate you for the phenomenal job you did with the Astronomical League last weekend. It was absolutely incredible. But I think the best part of it was when someone asked you, don't you ever get tired of doing all these Zoom meetings? And you said, no, I don't. I don't. I do it all the time. I don't get tired.
True. It's true.
I find that so hard.
I love what comes out of it because, you know, I mean, if I was just sitting down in private meetings, Zoom meeting after Zoom meeting, I'm sure I would get fatigued. But what we're doing is we're doing educational outreach in astronomy, and that I love. That is why, that's the juice for me. Okay, so you know, and had the pandemic had stopped that, I think I would need some psychotherapy or something, because I really do need to get out and share the experience. And good Lord, I love the team that comes together each time to do Global Star Party, to do, what I think is the best in astronomy outreach. You look at the people that come onto this program, it really is kind of like a dream team. And so I'm honored just to play a little part in it by using the software and the tools that are readily available really to anyone. But it does take a certain level of commitment to try to be there each week. But I love it. I'm always charged afterwards, even after the Global Star Party. I have a little tough time sleeping afterwards because I'm so energized. So, but and really it was the people who participated in the Astronomical League conference that made it. The executive officers put together an amazing sequence. I'm still getting phone calls and emails and texts about the speakers that were on there and how they really, you guys knocked it out of the park. It was just amazing, so David, you're David and David, there was lots of people who remarked on both of your presentations. Robert, you gave a presentation as well. Chuck Allen, his segues from speaker to speaker. It was easy to do, and everything worked. And so that's, I couldn't have asked for more. And it was just, I'll be remembering that particular event for a very long time.
As I think will the rest of us, it was really something. And unlike you, Scotty, I'm a little bit older and I do tire a little more easily than you do, but I love these things and I really do enjoy it.
Me too.
Anyway, today our theme is planets with rings. We're going to be talking about that. And I can't think of a better way of introducing planets with rings with talking about Jupiter, not the planet, but the cat. The cat is named Jupiter, and it belongs, I believe, to Dave Eicher. But as you know, as any one of us who have owned cats in the past know, that you do not own the cat. The cat owns you. You are part of the staff of the cat. Anyway, so Jupiter has rings, the cat, and the planet. And I really appreciate that you named a cat after what is clearly my favorite planet. In 1967, I was kind of quite into astronomy by then, and I was reading the New York Times. It was a Sunday edition, and I happened to fall upon a poem that they had about one of Saturn's moons. And since Saturn is a planet with rings, I wrote that poem, copied it into my daily diary, and I still have it. And I'd like to quote it to you now as the first of two quotations that I'm going to offer to you today. It's about Phoebe, the ninth moon of Saturn, because it was at the time the only moon in the solar system that was orbiting the wrong way. Now we found a lot of moons orbiting the wrong way, so we really don't know what is the right way, but this was something I would like to share with you. Phoebe, Phoebe, whirling high in our neatly plotted sky. Phoebe, listen to my lay. Won't you whirl the other way? We've prescribed in terms exact just how every star should act. Where to go and whirl at night. Phoebe, can't you get it right? We really know you are so strange, but really, we can't rearrange all the charts from Mars to Hebe just to fit a chit like Phoebe. And I really did enjoy seeing that. And I guess in those days, the New York Times really came out with some interesting stuff. Anyway, that was a long time ago. But to celebrate a long time ago, I'm going to now read to you a quotation that comes even longer ago. And this was written by Christian Huygens in 1656. And he was so shy about it that he didn't even write it. He wrote it, and then he took all the letters and poured them into an anagram with A's and B's. And when you deciphered the anagram, it came out to this Latin quotation. Annulo cingitur, tenui plano, nosquam coherent, ad eclipticum inclinato. And it's an interesting Latin quotation. When translated, it reads thus: it is surrounded by a thin, flat ring, nowhere touching, inclined to the ecliptic. And that's how Christian Huygens decided to announce his seminal discovery of Saturn's ring. And on that basis, I'm going to give it back to our host, Scott Roberts. Thank you.
Thank you. I love hearing about the history of discoveries of astronomical discovery, and sometimes you hear or you're also able to read about their feeling about it and stuff, and that just really gets to me, So. And it's interesting that he was so shy about releasing this information, this discovery. David, do you think it was because of, did he fear any kind of retribution, or,
I don't really think he feared retribution, but he probably remembered what his friend Galileo went through a few decades earlier with his discovery of the moons of Jupiter, and then the dialogue that he wrote, and the suffering that Galileo did with that. I'm sure that that was certainly in his mind. I don't think he had to worry about the same thing happening to him, but he certainly remembered what happened to Galileo, I think.
So he was careful, at least.
Just trying to be careful.
Just trying to be careful. Well, we don't have to be so careful anymore, except we like to get, scientists are saddled with getting the science right. And so with that, we will talk to Mr. David Eicher. David Eicher, if you don't already know, is the editor-in-chief of Astronomy Magazine. Like David Levy, he's written numerous books on astronomy and given lectures around the world, and he is a regular on the Global Star Party. I asked David, gosh, do you ever get tired of Global Star Party? And he's going, no, I have fun here, and that's the main point. We really do want people to enjoy, themselves while they're participating. David is, sorry?
It's a picture of Huygens from William Sheehan's book on Saturn.
Oh, okay, great.
I got it the wrong way. Anyway, yeah.
But I'll finish introducing David Eicher. David is, for those of you who have met him or know him, he's always full of wonder. He's fun, has a great sense of humor, and he is very knowledgeable. And so, it's a treasure to have him on Global Star Party. David, thank you for coming on.
Thank you, Scott. And thanks for everything that you do as a one-man outreach phenom for the astronomy world, doing all these things, and your great hosting of the League meeting, which was terrific. And thanks, David, for always inspiring us at the front end of these get-togethers as well, which are lots of fun, I think, for all of us. I'm going to see if I can share my screen. Oh, I'm sorry, David.
Just said thanks, David.
Of course. I'm going to see if I can share my screen and share some slides again. Can you see that?
Yes.
Let me see if I can start the slideshow of this. Can you see that okay now?
Yes.
Okay. Once again, I'm going to talk a little bit, not so much about planetary rings really tonight, but about minerals, as I like to say, how the universe makes planets. And as I've started off last week with a generalized talk as well, this is a nice tanzanite crystal, which is a beautiful gem silicate that's made into lots of jewelry. It's a purple variety of zoisite, which is an interesting complex silicate. But I thought I'd talk a little bit tonight about one of the most common minerals that makes up a huge amount of Earth's crust, quartz. Good old silicon dioxide, that's SiO2. That's one silicon atom and two oxygen atoms together and repeating. And it's very, very common. Now, they're interesting and beautiful varieties of quartz, but if anyone really comes at you and says they have some exceptionally rare quartz, no, they don't. It's very, very common as a mineral. So, but it's nice, and collectors are very much into it. So I thought I would show a few examples of some of the colors and varieties of quartz and how you can hold a piece of our planet and imagine what other planets might be like as well, because of course chemistry is universal in the universe, in your hands if you'd like to as well. Gives astronomers something to do in the daytime, perhaps, collecting minerals and meteorites too, when the sky isn't dark. So this is a diagram showing the basic structure of quartz, and the silicon atoms are the white atoms and the red atoms are the oxygen atoms. And its basic sort of repeating pattern there of crystallizing. Again, there's no magic to the universe. As much as we love science fiction and we love stories about things and human culture, we don't have to invent magic to understand what the universe is doing. These atoms in the right pressures, temperatures, situations, and availability of mineral fluids are electrochemically attracted to create to each other to create minerals in the same way. So that this is the way the physics and the chemistry of this stuff works. We don't need any kind of magic to understand the universe. Quartz has a whole bunch of so-called crystallization habits. Of the crystallography of quartz can be fairly complicated, and it can crystallize in different shapes. Here you can see rhombohedra and hexagons and pyramidal crystallizations and trapezohedrons and so on. And so you can see quite a number of types of quartz crystals that exist, as well as quartz is really, really commonly crystallizes as a so-called cryptocrystalline mineral. That is in tiny, tiny, somewhat less organized crystals, and that makes up some of the more interesting types of quartz as well that we'll look at. So I just thought we'd run through now a few of these and kind of share what this mineral is all about. The basic kind of quartz is just quartz and really clear, like the top crystal here on this grouping. Clear crystals like this are called rock crystal because early on in various alpine and other locations, they looked like frozen rocks to early explorers. So this is from near Diamantina, Brazil. It's a fairly, common kind of quartz crystallization there, and you can see it has multiple kinds of crystal faces on this specimen, but very common stuff and very pretty nonetheless. Well, quartz, like all sorts of minerals, gets contaminated by what mineralogists call chromophores. That is some little impurities within the mineral. Every few atoms ends up being something else. And so a variety that's very pretty and often used for jewelry. Quartz is, of course, very, very hard. So it can be cut and made into jewelry very easily because its hardness is so great. Rose quartz, as this is a little crystal grouping of, is often contaminated by iron, titanium, or magnesium atoms that give it its color, which quartz in and of itself is colorless. Well, then another very common kind of quartz, and where is this from? This is from Colorado. I'm trying to forgive me, I don't have all of my labels. Some of these are packed away, some of these specimens, but I have some labels here. This is quartz on a common mineral that's called microcline, and this is from Colorado, from the so-called Crystal Peak area in Telluride, in Teller County, forgive me. And this is what mineralogists call smoky quartz, that kind of smoky color of quartz crystals. This does not occur from a chromophore. Smoky quartz is produced through radiation. It's not dangerous, it's a low level of radiation has turned the color of these quartz crystals. Of course, remember, even you have radioactive elements inside you, and many things around us like potassium salts are very weakly radioactive as well. So that's nothing to fear ordinarily. Remember that if you eat about 200 bananas a day, you can give yourself radiation poisoning. Bananas are radioactive at a very low level. So this is where smoky quartz comes from, radioactivity. Well, this is amethyst quartz, this purpley color quartz crystals. This is a specimen from a famous locality called Las Vegas, Veracruz, Mexico, where a lot of the best of this stuff comes from. And it's contaminated by a variety of little atoms that turn it purple. Another variety of quartz is so-called red quartz. You can see this is very strongly and almost uniformly colored red. This is from the Second Sovietsky mine in another famous mining region that's called Primorsky Krai in far eastern Russia. And a lot of good red quartz comes from that area. Red and yellow, often with minerals as colors, and this is the case with quartz here, comes from a little contamination from iron atoms. Here's another example of a different kind of red quartz, a single little crystal here that's from a famous area of Namibia called the Orange River area. This again is colored by iron atoms, and it almost looks like a coating on the exterior of these quartz crystals from Namibia, but they're actually included within the quartz mineral, that coloration. Here's another example of a different Mexican locality for a very deep colored amethyst, very popular stuff. Now, cryptocrystalline quartz, rather than big crystals that you can see, cryptocrystalline quartz creates a lot of varieties of quartz that are colorful, often like this one, that have names like agate when they're cut and polished, or chalcedony, and oftentimes they're made into decorative pieces or jewelry. Well, this is a piece of agate that's been sliced and polished here. That's a nodule. It's about 6 centimeters across. It's from Queensland, Australia. And again, the orangey and yellowish coloration here comes mostly from iron. Here's another one. There's a very famous locality of these beautiful agates. And you can see this is a geode that has formed as a very dense quartz rock. And fluids have flowed into and through this geode as it crystallized over a long time. And the chemistry of those fluids, as you can see, which contained a lot of iron at various times, changed over long periods as it crystallized and gives us these beautiful pieces. This is from Argentina, and these are called condor agates from the region there in Argentina. This is an Australian piece here. It's a variety of another cryptocrystalline quartz, very small crystals of quartz called chrysoprase. It's colored green from various nickel compounds that are very rich in the element nickel, particularly a mineral called willemsite. That's a nickel mineral. And chrysoprase or chrysoprase is also used a lot for jewelry. This is an unusual one that comes from Pakistan, and I don't know if you can see, but from upper right to lower left, there's sort of a thin, small crystal of quartz that runs through this specimen that has sort of tabular crystals on it of quartz. This is what's called a Faden quartz crystal, in which the long, small crystal acted sort of as a seed, if you will, and other crystals attached to it as more silicon and oxygen atoms were available, and it built up these larger crystals on this thread, if you will, of quartz. There are also varieties. Some of the good ones, like this one, come from Spain, of blue quartz, which is an unusual color in a mineral like quartz. This comes from contamination of a few kinds of unusual silicates: magnesio-riebeckite, crocitolite, or various minerals from the tourmaline group, often color quartz blue like this, which is quite unusual. And then this is also an example of a clear quartz crystal. This is about 4 centimeters high, this one, and it's sort of heart-shaped. You can see there. There's a thread that runs down kind of the right center of it. And this is what's called a twinned crystal in mineralogy, and that is, it happens when there's a growth fluke, this kind of twinning. It's called a Japan law twin. And that's because the best specimens of these often came early on from Japan. This one is from Peru, however. And it's when there's a fluke in the growth of the crystal and it creates a mirror image of itself. So you can see there's a right hand and a left hand crystal there that is so-called twinned and grew up as there is more material available as a sort of mirror image, if you will, of itself. So those are a few examples of quartz, of the different, oh my gosh, oh, that's the end of that, I guess. I think I had one more slide, but I'll have to do that next time. So anyway, that shows you a number of the varieties of quartz and the colors that you can get in a single mineral. Often have many, many, many colors and forms, so-called crystal habits. And again, that's the way the universe likes to build up organized elements into planets, the things that make up our solid terrestrial worlds. So again, thank you very much, Scott, for the time. And I will stop sharing my screen.
Thanks for sharing your collection. There was a question in the audience, wanting to know if that was your personal collection of crystals and minerals and stuff that you've been showing.
It is, and I'll make a long story short. My father was a professor of organic chemistry, and he contaminated me with many, many problems, interests, through exposing me to these things: American history, science, chemistry, astronomy, mineralogy. In the 20s and 30s, when he was very young even, he went out and collected lots of minerals. They're not so pretty. They're called ore minerals, that are the kind of minerals, rocks that were found that led to gold and silver mining, mostly in the American West. I got turned on to all of this stuff and started collecting, and for about 15 years put a collection together of about 1,800 of my own specimens, which which now, the way you collect now, because lawyers are worried about people falling down mine shafts and suing an inherited company for $100 million, so you can't really go. It's very hard to go and collect things in the last generation yourself. Now you have to go to things like the Tucson Gem and Mineral Show or the show in Munich and collect things from dealers there. So for about 15 or maybe a little more years than that, I've put together a pretty decent collection of about 1,800 specimens that I will torture you with a few examples for a few more weeks with.
I think people love it and they're mesmerized by it. There was some questions about gold and in quartz. He said, Book Davies says, I've heard, but I don't know if it's true. Does gold tend to follow in quartz seams?
Absolutely. Yes, and the American West is one of the best places to see this, where the mountains have been pushed up. Now, gold is a relatively common mineral in the universe, and it was created, gold, silver, and platinum, by the collisions of neutron stars, believe it or not, those elemental atoms. But it's hard to find on Earth, and they're treasured, those things, including gold, primarily for jewelry, of course. If we could get all of the dissolved gold that's in seawater and recrystallize it, it would be worthless, but we can't. So it's hard to find. And for a couple of hundred years in the United States and in Australia and South Africa and lots of other places, people have mined gold, and it's been a major attraction. And yes, indeed, it does tend to crystallize along with quartz veins. So the miners in the early days in the West, following the California gold strike, and especially in the boom days of Colorado gold mining, would try to find rich veins that were exposed on the surface of quartz, cross their fingers, do some digging, use some gunpowder, and hope that they found a rich vein of gold intertwined with this quartz. Now, the problem is that quartz also hosts a lot of other things, like pyrite, that looks superficially like gold and is pretty worthless. So therein lies the challenge of finding gold. But the answer is yes, gold and quartz are often intertwined in veins.
Well, one thing I would like to add is that I did have the honor, Wendy and I had the honor of meeting your dad. And I will never forget when we got you and him together here to watch the movie Lincoln, which I've always remembered. And I have a little thing to show. This is a Gibeon meteorite that I want to share with you. It's right here.
A Gibeon
It's
ring,
a little meteorite. It's a ring, which I use as my wedding ring. And Frank Lopez was able to make a ring from this piece, and I really treasure it. It is my wedding ring.
Very nice.
That is
Very
fantastic,
nice.
David. And of course, that's iron nickel, the iron meteorites, and a little very small amount of heavier elements as well, but mostly iron and about 7% nickel, and is very, very good for cutting and making things because it's very dense. Beautiful. Thank you, David.
Wonderful, wonderful. Well, we look forward to learning more about your mineral collection, David. That's great. That's great.
Thank you, Scott.
Many of us, at least certainly in my generation, boys and girls like to get the little, quartz and mineral collection kits. A lot of times you'd see them on roads, like on Route 66, they would have these shops, and you would see these little things. And I had several of those collections as a kid and just really marveled at them. And when I go to places where I see large specimens, it's just dazzling, so.
Scott, I do have a warning to issue to the whole community. Because once you start with whether it be minerals or books or telescopes or documents from the past or stamps or coins or whatever, once you get that collecting infection, it doesn't go away. So be careful what you wish for, kids,
right?
Because this is addictive
You have to have whole rooms to store it in, I'm sure.
Yeah.
Well,
David, you're gonna have to add photons from the night sky to that, because as soon as you start collecting those, you keep wanting to go out. Doesn't matter how much sleep you don't have, you're just gonna go out and get them.
Yeah, the photons are nice and compact, though.
Yeah,
But
and fit in pictures.
Books don't classify as that.
Right. I like to
I only
collect.
have a library of about 6,000 books. I did want to say, you mentioned about California and gold mining. After they were running out of gold in the panning, they started doing hydraulic mining, where they brought water from higher points on the river and sprayed and washed down the mountains. This was like in the 1850s and 60s. Just a few years ago, they finally announced the San Francisco Bay Area, the water, the San Francisco Bay, was starting to get clean because all the silt from all that gold mining had finally washed down the rivers.
Finally. Wow.
It was
Wow.
heading out to the bay. If you go from Sacramento up to Tahoe, provided there's no fire closing the road, along the foothills, there are these big mounds of river rock that the miners just piled rocks along, and then they built the road nearby. And so as you're going along, there's just all kinds of river rocks, old mounds, and on the other side is where they washed down the mountains. So that's obviously been stopped, but that was how they got to the gold as fast as they could, by washing down the dirt and then trapping the gold.
Goodness.
Sure. And if you drive through the San Juan Mountains in Colorado, randomly through the San Juans there, you can see, mine dumps left and right of most of the roads everywhere you look, and of course, in the old days, the mother lode in California was run through relatively quickly, but the mining in Colorado went on for a much longer period. And of course, early on, up and even until the early 20th century, the mills to leach the gold out used cyanide, so you're right. Mining didn't, our lust for jewelry and other valuables didn't do Earth a lot of favors, in terms of taking care of the planet.
Or the miners.
So there's some cleaning up to do.
Or the miners. Yeah,
Oh,
you're
yeah.
right.
Or the miners. Yeah, exactly.
Yeah,
but you're
Dave,
right, Adrian, about collecting photons. That's maybe more addicting than any of these things. Yeah.
That's right. But you know what? It keeps our illustrious head of the Global Star Party in business. Explore Scientific with all the telescopes and all the gear. So there's some benefit to seeking out photons.
Yes.
And as we like to say, it gives us something to do while we're stuck down on this planet for a while.
Yeah.
I guess I'm going to have a little label on the telescope that says "Look responsibly."
You will.
Okay.
I think you will need that. And really quickly, one thing the pandemic has done, and we talked about a little earlier, brought attention to other things that you can do, like look up at the heavens and see things that are there that a lot of people may not have paid attention to. Those that are watching and continue to watch this Global Star Party are getting a better appreciation of it, and all the star power, pun intended, that comes to the Star Party. All of you that have written books and that I'm learning from, it's an honor to be a part of this group and take an even deeper interest myself in some of the things that I've taken pictures of. It's no longer just a picture. There's something behind there that tells a story. Every single star in my virtual image tells a story, and you see how many millions of them there are. So that's a huge impact of the Star Party. We're talking about all the ringed planets, and I'll be looking forward to seeing if anyone talks about the exoplanet that's supposedly Earth-sized but has rings galore, stretching. I forget if they stretch the distance of the solar system, but anyhow, it's great being a part of this group.
Yeah.
And great talk, David. Enjoyed it.
Thank you, Adrian. That's great. Okay, well, so up next is it will be Chuck Allen from the Astronomical League. The Astronomical League, we just did Alcon, the virtual event, which was great for all of us. I think we all still have a buzz from that. Chuck is also going to give a presentation later in the Global Star Party. But for right now, he's got, we have the business of door prizes and some announcements from Chuck about the Astronomical League. And Chuck, are you there?
He's on mute.
Sorry about that. Thank you, Scott. And with regard to the convention, I owe a great deal of gratitude to many of the people here tonight and to a lot of people out there who supported us as speakers and door prize donors and all the award winners who showed up and everything stayed on schedule, and Scott's platform was just miraculous. And Scott, thank you for sitting there for 27 hours and monitoring everything. It couldn't have been done without
It
you.
was awesome. It was awesome.
And if you want to know about tension that was associated with this, after it ended on Saturday night, I did a good deal of sleeping, and I woke up and desperately realized that I didn't know what time the GSP started. And I had to get this little mini program ready. And I tried to reach Terry, who was traveling. And when I finally reached her, she informed me that no, it was not Tuesday, it was only Monday. So that's the condition that was the condition I was in at that point.
Well, the first posters I put out, I also put the wrong date on it. So, I was also, a little bit lagged, but.
So I can show
anyway,
it.
I'll thank John Goss for correcting me. So we all kind of prop each other up.
Okay, let me share screen here for a moment. There's one, let's see, slideshow from current slide. Well, that's odd. Let me try it again. Okay. Okay, I'm going to do this the hard way, folks. Hang on.
Their slideshow engine burned out from so much use over the past couple of days.
I think it probably did.
Yeah, need a new bulb.
Yeah.
Mm-hmm. You may have also saved the file as as you were saving it, you might have saved it as a slightly different version, which I run into sometimes.
Don't think so.
Okay.
Let's see. Okay, folks, hold on just a moment. Okay, that page is open.
While Chuck is looking at that, I'll remind the audience that we have Tom and Linda Spilker of Voyager fame will be on tomorrow, starting at about 4 p.m. Central.
There we go.
And there you are.
I wanted to point out that the Astronomical League Award is the highest award given by the Astronomical League, and the award was founded in 1951. And you can see a list of past winners of this award here, and it's a who's who in astronomy. And we were proud this year to award 2 Astronomical League Awards, one for 2020, which we didn't get to award last year, and one for 2021. And our winner for 2020, and Scott, forgive me, is Scott Roberts. And this picture will give you some idea of how long he's been supporting us. For nearly 30 years, he has supported our NIA award by sponsoring the prize that goes to the winner. He's engaged in a constant promotion of the Astronomical League. His virtual convention support was absolutely critical to the success of our convention just completed. He's made door prize contributions and provided his platform support for us and our live events, and also for our appearances on GSP. And Scott, congratulations to you, and thank you for all you've done for us over the years.
Thank you. I did not need any special recognition for doing that. I really love what I do, and love the league and all that it stands for and all that it does. So.
Nonetheless,
when I look at that list, I go, "Oh my God, yeah. I don't belong here."
Yeah, you do. You absolutely
yes, you do, Scotty. You really do.
Okay. We always like to put a solar warning up before we do our door prizes, because I think it's a good idea for beginners to realize that you can't afford to make even a microsecond's mistake with regard to observing the sun. It's not to be done by people who do not know how to do it properly. There are people in local societies near you who do. You do need proper solar filters that include energy rejection filters mounted at the front end of the telescope. You do not use eclipse glasses to look at the sun through binoculars or a telescope. They will simply melt. And never leave a telescope or binoculars unattended where children might get a hold of them in daytime. That could be a problem too. So moving on to the answers from GSP 58. We had a question: how many of Earth's robotic landers have landed or crashed on extraterrestrial bodies in our solar system? Actually, this was sort of misphrased, and we apologize for that. There have been 94 such landings. So we figured most people would understand that we were asking on how many different extraterrestrial bodies we have made landings. And the proper answer to that is C, 14. We've landed on Mercury, Venus, our moon, Mars, Phobos, Jupiter, Saturn, Titan, 4 asteroids, and 2 comets. Question 2, the moon has about 1/6 of Earth's gravity. What is the gravity of Mars when compared to Earth? The answer is 38%. And the Astronomical League has a lot of observing programs. One of them is in celebration of our 75th anniversary. This program challenges observers to make 75 observations of Jupiter. What are the 4 brightest moons of Jupiter, which are often called Galilean moons? They are Callisto, with 2 L's actually, Europa, Io, and Ganymede. Correct answers from GSB 58 were given by these individuals. So congratulations to you, and you will go in the door prize list for the end of the month. Okay, now our questions for tonight. Remember to send your answers to secretary@astroleague.org by email, secretary@astroleague.org. That address will appear at the bottom of each slide. In 1967, this graduate student stumbled upon a pulsing radio signal that turned out to be a new class of objects consisting of rapidly spinning neutron stars that were created in supernova explosions. Who is she? If you watched the convention, you might have gotten to see her. Question 2, who designed the optical arrangement, parabolic primary mirror and a flat secondary mirror tilted at a 45-degree angle to the primary used in this telescope? And 3, Johann Gottfried Galle was the first person to observe a famous object and know what he was seeing. What was the object? Okay. Please join us on September 17th at 7 p.m. Eastern Daylight Time for Astronomical League Live Event 9. We will have Claude Plymate, who will speak on astronomical adaptive optics, a very interesting topic to be sure. So we'll look forward to seeing you then. Thank you very much, Scott.
Thank you so much, Chuck. That was great. I guess I feel a little embarrassed, but thank you, everyone. It was so nice. Up next is Karim Jaffer, Professor Karim Jaffer from John Abbott College. He is also someone that's incredibly involved in educational outreach, real inspiration from the Royal Astronomical Society of Canada's Montreal Center. And he is, I've said it before and I'll say it again. I wish that if I'd taken classes in astronomy at a university, I wish that Karim Jaffer was my instructor, because he is really gifted in presenting these kinds of materials. He knows his subject. He makes it easy to understand by almost anyone, and that's a real gift. And so, Karim, thank you for coming back on the Global Star Party.
My pleasure, Scott. And this time you're making me embarrassed now. I will say, Chuck, those are fantastic questions, and I seem to be making a habit of giving away the answers to some of the questions in my presentation. So if people keep an eye out, they'll see the answer to at least one of those questions today. So when Scott announced the topic for ringed planets, that just rung a bell for me, no pun intended. I was really looking forward to talking about this. So it's our first week of classes, but I couldn't pass up the opportunity. Now, Scott does a great job of making individualized posters for each of us for every GSP, and I normally put those on my slide, but I thought today, instead of the individualized poster, I would share a picture my daughter took of me this summer where I had ringed planets in my eyes, on my mind. And I just love this picture because it just fits perfectly for tonight, because we're going to talk about ringed systems. And what I want to share with you over the next few minutes is the initial observations of a lot of the ringed planets and systems within our solar system. So I'm just going to start right off. We're not going to do a check-in today with all the different things that I'm doing. I just want to jump right in, because when we talk ringed planets, in all of our minds, the first one to pop up is typically Saturn. No offense, David. Jupiter still pops up when I talk planet, but when I talk ring planet, it's typically Saturn. And part of the reason is because we go out for our public nights, we go out with friends, we go out ourselves with binoculars, with small telescopes, and we can see Saturn. We can see it move into view. We can see that gap between the rings and the planet. And it's a very narrow field of view. We have to magnify it a fair amount to be able to see any detail. But that little blurry view with the rings and the space between the planet and the rings is what was the initial observations. When we look for pictures of Saturn, we tend to see something closer to this, which is, taking a good 30-second video of a fair amount of detail, being able to stack it and use wavelets and draw out a lot of the contrast and a lot of the beauty, even be able to see that hexagonal pole that it has, which is just absolutely amazing. You can even see the Cassini divisions in these types of pictures, but those aren't your initial observation when you first look at this ringed planet. So when we're talking about Saturn, the first person to actually look at it through a telescope that we know of historically was Galileo. And when Galileo looked at it in around 1610, he saw that type of a fuzzy picture that I showed you before. And he identified it as an object with two lobes, two what appeared to be moons, a three-body object. Now, part of that might have been biased by his observations of Jupiter with the 4 Galilean moons, but at that time, that first initial observation by Galileo was when Saturn was close to reaching the sunset moment where we wouldn't be able to see it again for a little while because it was on the other side of the sun for us. So he waited and he took more observations. And unfortunately, when he took more observations, he couldn't see the rings. He couldn't see the lobes. Now, at that point, the idea of the Roman name or the Greek name for Saturn, Kronos, kind of pops into mind because Kronos was a Titan who actually ate his children. So the idea that all of a sudden those moons are gone kind of fits that legend. But that's not truly what happened. What happened was that in 1612, when Saturn had come back around and Galileo was paying attention to it, what the orientation of Saturn was an equatorial orientation, which is when the rings actually disappear for a few brief days, but for a long period of time, they're very hard to detect, especially with the optics that Galileo had in the early 1600s. Our next moment of this type of equatorial view of Saturn is going to happen, I believe, in May 6, 2025. So we're pretty close to getting that view of the rings edge on where we can't see them because they're so thin. So we now know that that's what happened. Luckily, Galileo was persistent, so he kept after it. And for the next few years, starting around 1614, he was making observations of Saturn, and he saw that there does seem to be some sort of a gap or something between what that arc was and the planet's body itself. So he called those the arms of Saturn at that time. After that, we really didn't know what exactly we were looking at. And around 1655, Huygens, as David talked about earlier, he kind of proposed this idea that there were solid rings. He had also identified the moon of Saturn, Titan, and at that time, they weren't quite sure what the rings might be. In 1660, several scientists tried to give the idea that they might be just composed of a bunch of small moons. And in 1675, Cassini identified more larger moons around Saturn and a division within these rings, the Cassini division. And when he first identified that division, that broke the idea from Huygens that these were solid rings. It wasn't until the 1800s that Keeler first put forward the idea that these were actually composed of a bunch of smaller particles. We now have some amazing observations of Saturn's rings, not just from here on Earth, but also from probes that have gone near Saturn. In 1981, Voyager 2 passed by Saturn. And when you take the images from Voyager 2, and you use false coloring, you can actually identify layer after layer after layer of those rings. When you look at those rings, one of the things that you find is there seems to be perturbations, little wavelets. And in 2013, Cassini actually was able to catch pictures of that gap, the Encke gap, and saw the moon pan moving through the gap and leaving behind these waves. And those waves are gravitational perturbations of these small particles that make up the rings of Saturn. And those are mostly ice particles, which is why those rings shine so brightly. That perturbation was detected in the Voyager 2 pictures. And so when the Cassini probe was there, they were actually able to identify what was causing it. And it's this beautiful little moon pan, which collects dust and keeps that gap free. Towards the end of Cassini's life, it actually dove in between the rings just as it was going to enter the atmosphere. And as it dove in between the rings and the planet, we have a lot more data that we're still identifying and still really just processing. Now, we have some beautiful pictures of Saturn that are taken by the astronomers that present here. So I'm going to leave Saturn behind, and I'm going to talk about the next planet that we realized had rings, which was Uranus. Now, Uranus was initially discovered by Herschel using his 40-inch telescope. And Herschel was following after Uranus because he thought it was a comet. And when he realized that it wasn't a comet and it was a planet, many other astronomers of the time realized that they'd been observing Uranus, they just hadn't figured out what it was. Now, when Herschel recorded his observations, he actually recorded having observed a ring, and nobody believed him. Nobody believed him because nobody could substantiate this claim. However, his recording of that ring was a different orientation and relatively reasonable in size to what we actually now know to be the rings of Uranus. So it's possible that he actually did discover the rings of Uranus.
Oh, wow.
But what we go with for the actual observation and the actual first discovery is in 1977. And that video that Scott started us off with tonight talked about transits of exoplanets in front of their parent stars. We actually can use occultations of planets close to us, covering over a star far away in order to examine those planets. And so in 1977, the Airborne Infrared Telescope on the Kuiper Airborne Observatory was going to try to measure the width of Uranus by following it as it occulted one distant star. And what happened was before the occultation and after the occultation, there were a series of 3 dips. Those series of 3 dips were the clear evidence that there were rings around Uranus. 1986, Voyager 2 went by Uranus and was able to take pictures of those rings directly. And you were able to see pictures not just of the rings backlit, but also frontlit by the sun. And when you see them, you see that that outermost ring is actually much brighter than the others. So there is a small chance that Herschel actually did see those rings. Hubble turned its attention to Uranus in the early 2000s and actually identified outer rings that are much, much larger than these inner rings that Voyager had seen, but they're incredibly faint. Now, why are they so faint when most of these rings are actually made up of methane ice? And what it's believed is that because methane has so much carbon, they believe that the carbon is actually transformed into a little bit more graphite, which ruins the reflectivity of these rings compared to Saturn. Now, Jupiter, I have to talk about Jupiter because Jupiter is our giant planet that we didn't know had rings until Voyager 1 came up. When Voyager 1 came and was approaching Jupiter and then passed by Jupiter, it took multi-exposure images. And in those multi-exposure images, not only do you see the background stars moving around, but you see this strip of material that's reflecting sunlight. That strip of material reflecting sunlight was actually these very, very dark rings. Now, Voyager 1 was the first to see these. And when Voyager 1 saw these, it immediately struck people that why are we not able to see these from Earth? Because Jupiter is so, so bright. So the idea became that these were very dark bits of material, likely debris from moon impact rather than being water ices themselves. Voyager 2 had actually taken a picture from behind Jupiter of the end of the rings to show that there was a difference in density and reflectivity when you move closer and further away from Jupiter. So now here's one of the really neat things that I found. When the Galileo probe went to investigate Jupiter, one of the things they had it do was to examine the rings of Jupiter more directly. And it found a wobble in the outer rings. Now, that wobble in the outer rings was something that was not expected because Jupiter's gravity is so strong. Computer simulation shows that the likely cause of this wobble was Shoemaker-Levy 9, because that had happened 2 years before. And the gravitational pull of those remnants of SL9 as they collided with Jupiter and went close to the rings likely caused those ripples, and it would take many years for those ripples to smooth themselves out. So in the rings of Jupiter, we see evidence of the impact of SL9. One of the things that Juno satellite has been able to do is actually dive inside the rings. And it did that right away in the very first perijove. Its first pass by Jupiter, it dove into the magnetic field lines and in between the rings and the planet. And it took pictures of the rings with the stars behind, and you can actually see Betelgeuse just above those rings in the view towards the rest of the solar system. Since then, our infrared technology on Earth has allowed the IRTF, the Infrared Telescope Facility in Hawaii, to be able to image the rings directly, even though visibly they don't give off enough light. In infrared, they do. And that actually gives credence to this idea that they're made of moon dust. Now, Neptune was the last of these giant planets whose rings we figured out. However, the first recorded observation of Neptune was by William Lassell in 1846 of the rings of Jupiter. It was 70 days after Galilei had actually discovered Neptune. What Lassell saw was unknown because he wrote about a ring, but nobody else could see it. Nobody else could confirm it. But one of the things that I found really interesting is Galilei found Neptune based on mathematical predictions of the location of Neptune by Leverrier. So Lassell, the reason why he was able to tune in and really be able to follow Neptune was because he was the first person to use equatorial mounting for a reflector telescope, which allowed him much longer, much smoother observing sessions. Now, that was all the way back in the mid-1800s that he felt that he had seen a ring. Nobody could confirm it. In 1968, there was another discovery of a partial ring, but again, nobody else could confirm it. In 1984, 5 rings were seen and confirmed by the European Southern Observatory, La Silla Observatory, and then they were imaged in 1989 by Voyager 2. Voyager 2 took 2 very long exposure pictures on either side of Neptune, and all of a sudden you could see the rings of Neptune. And those rings of Neptune are really peculiar compared to all of those other planets that we talked about, because those rings are not all complete rings. Some of them are just arcs. They're arcs of material with no combining material between those arcs. So they're not one full ring. But the other weird thing is, all of these rings seem to be different in density, and themselves, they don't have a consistent density all the way around. So the rings of Neptune are actually a big puzzle in terms of exactly how they're created and exactly how they're maintained and why they seem to be a persistent feature. They're also along the equatorial plane, while the largest moon, Triton, is actually on an angle. So one of the suppositions is that the arcs are there because every time Triton passes by, it breaks up that outermost ring. And so that might be part of the issue. Now, those aren't the only ringed systems in our solar system. Chariklo, one of the largest Centaur planet in our solar system, which exists in an orbit between Saturn and Uranus, was actually found in 2014 to have 2 rings. Now, what a Centaur planet is it's a dwarf planet that sometimes exhibits an atmosphere. So it sometimes looks a little bit like a comet. Sometimes it looks a little bit like a moon or a dwarf planet. So we call it a Centaur planet. Those 2 rings were observed by that same ESO's La Silla Observatory. They were infrared observations of an occultation. And so if Hubble tries to take a picture of Chariklo, this is the most precise picture that Hubble can take. This shows no evidence of any rings. So it's only through these occultations in certain wavelengths that you can occasionally see the evidence of these rings. But the evidence of the rings has actually been confirmed. So an artist's rendering of what they think Circulo looks like is here. But again, that's not the only Centaur planet with rings, because Chiron has a ring system as well. And it was seen to have 3 occultations all showing a ring system. And so once the third one happened in 2011 with more precision, they felt confident enough to say, yes, this is a second Centaur planet with a ring system. And on top of that, we now have another dwarf planet all the way out, Haumea, which we now know to have a ring system. But that ring system is one that we really have no clear idea on what makes up that ring system. So in our solar system, these are the ringed planets that we have in our neighborhood. Scott, back to you.
Wow, quite a few ringed planets, and even in our own solar system, and undoubtedly, as we, certainly we have the one exoplanet, which a lot of us have been marveling at, that has, I guess almost a solar system wide ring system. So it's just really incredible. I wonder if, there's some comments by researchers that ring systems may be, very temporary in celestial age terms,
So if you look at a lot of the ring systems, the ones that are in these dwarf planets and Centaur planets that are kind of by themselves are most likely temporary. They're just a temporary gravitational attraction of material.
Mm-hmm.
But things like Saturn bring that into question, because in Saturn, you have the moons and the moonlets actually feeding in and helping to shepherd the ring system and keeping it stable. And in Jupiter, we actually feel like it's the moons themselves that are creating the ring system. So that one is probably a more transient function. For Neptune and Uranus, the weirdest thing about those 2 planets is that their magnetic field is so bizarre compared to all of the other planets in the solar system that we don't know exactly how the rings will interact with the magnetic field. Whereas in Saturn, they actually help each other out. The magnetic field can transfer materials from one moon to the rings or from the rings to another moon.
Amazing.
So Karim, is that what we have to do to collect the garbage around the Earth? Is to put some asteroids around the Earth to collect the garbage and get it into certain ring patterns?
I think we're gonna have to create some artificial ring systems.
Yeah,
right. Maybe some
gonna...
sticky asteroids that just collects everything. So.
Yeah, I was gonna remark that we may be able to consider Earth a ring planet as well, considering all the things we have orbiting around us. But that would be a good way to make the rings look a little cooler.
And I would like to also congratulate Karim on a very interesting presentation. But more than me is that Wendy really enjoyed your presentation, and it ain't easy to get Wendy to give a compliment.
Thanks so much, Wendy.
One thing we were talking earlier about our first views of Saturn before we went live. One night about 20 years ago, I had my telescope out in the front lawn. That's where I observed the moon, because I have street lights all around me.
Yep.
And 2 women came walking down the street, and one of them said, can you see stars through that? And I said, sure. And I switched it over to Saturn, and they looked at Saturn. They'd never seen it before. One of the women asked, where did I have the picture of Saturn inside the telescope?
Yes.
She could not believe she was looking at it live. But what is really a thrill is to go up to our Fremont Peak Observatory Association telescope up near San Juan Bautista here in California. We have a 30-inch Newtonian that was built by Kevin Medlock, who used to work for Celestron, if you don't know Kevin and Debbie.
Great telescope builder.
And it is absolutely incredible, the view of Saturn or Jupiter or even Uranus and Pluto through that 30-inch. Now, I know all the guys at the Astronomical League were showing off their equipment, which were all very fascinating too, but none of those can compare to the 30-inch. And it is mounted. It's, not equatorial, it's English mounted unit. It's open Friday and Saturday nights usually. We won't have any programs this year because of COVID, but I started going up there in the early 80s before we even had an observatory, and it's in a park. It's Fremont State Park, and it is open, and people do camp up there. You can pay and stay overnight, and then go down to San Juan Bautista Sunday morning for breakfast and such.
Nice.
Very, very thrilled place, and everybody shares their scopes.
That's
Yeah.
wonderful.
Enjoy. And David, thank you for screwing up Jupiter's rings with your little comment.
It adds flavor to the rings when they have some disturbance, some wavelets there.
Right. Is that an effect
There's
that's
a-
still going on now?
No, I don't believe so. But
Okay.
the fact that Galileo probe was actually able to take the picture
Yeah.
and that it matches computer simulation of what the effect was of SL9 going through was just phenomenal. That paper is just fantastic.
That's amazing. Well, that's great. Thank you, Karim. Thank you
My
for
pleasure.
also, I know that you had a time crunch, so I'm really, really happy that you were able to make the Global Star Party. Thank you. Our next speaker here is Bob Garfinkle. And I think I might have met Robert years ago, but I got to know him better at the Arizona Dark Sky Star Party.
Riverside Telescope Makers Conference, when you were still screwing around with me telescopes.
Yes, that's right. That's
so
right.
we were both little kids at it.
Right.
It was
That's
back
right.
in the 90s when I was selling star hopping.
Right. And that's one of your best-selling books. You have I don't know when you started writing about astronomy. It may have been from your youth, but you've written some incredible books, and I think your latest book is Luna Cognita. Is that right?
That's correct.
Yep. And you are a fellow of the Royal Astronomical Society. You are well known for being a historian of astronomy, which is great. And and you presented at the Arizona Dark Sky Star Party too, and I recall that, which was a great lecture. And so I'm going to turn this over to you, Bob.
Okay.
Thank
you very much
coming
for
on the Global
inviting
Star
me,
Party.
Scott. Yes, we did meet at Riverside Telescope Makers. I was a professional technical writer with Westinghouse, writing defense stuff. I purchased a Victor 9000 computer in 1982. My voice may cut it out every once in a while because of the strokes I had. And I was writing computer software reviews for the Victor because they were slightly different than IBM PCs. And that magazine folded, and I started writing book reviews for Astronomy Magazine about 1984, 85, something like that. And started writing star hopping articles for the magazine. And we decided to put a bunch of those articles basically into the book, which was was published in 94. But while the manuscript was out of my hands and was with Cambridge, I started writing what became Luna Cognita. It was just a nomenclature book, because as a kid, I was always wondering what the names on the moon were for. The one I like to point out is Alphonsus. I had no idea who Alphonsus was or what it was named for. Finally, it turned out it was King Alfonso X of Spain, Seville. So this was probably before the internet, obviously, and finding material was searching bookstores and libraries and whatnot. So you mentioned about my being a historian. Yes, I have a degree in history and a degree in English literature. And I am the historian for the lunar section of the BAA and book review editor for JALPO, for the Journal of the Association of Lunar Planetary Observers, plus doing all the other writing and keeping busy,
Stay busy. Oh yeah.
But I started in 1989. In 1991, I met Harrison Schmitt on a cruise for the eclipse on the Viking Serenade off of Baja. Ed Krupp, who's still the director at Griffith Observatory, called it the mother of all eclipses. After seeing Harrison's talk, I asked him if he would write the introduction for my lunar nomenclature book. He agreed. So it's taken well over 30 years to finally get that out. Anyway, I would like to share my screen and talk about fantasy flights to the moon, which is also part of the book. Let me get things going here. Let's see. I hit share. I don't know what that is, but anyway.
Yep, you're starting to share now.
Okay.
There we go. That's your desktop.
Yep. Yeah, it's the a mess, but opening PowerPoint is taking time because all the Adobe software now is on the cloud, and so they have to say, yes, you have a legal copy, not a copy hijacked from China or something. So here we go. Yep. Okay. All righty, let me start the show. Okay, so it's Fly Me to the Moon. And I like to dedicate my talks to Mike Reynolds. Mike was the Alpo director for a number of years, but I first met him when he was the director of Chabot Observatory in Oakland. And he oversaw the development, the building of the now Chabot Space and Science Center. Mike was the director for Alpo for the transits. And I was going to meet with Mike in Jacksonville to watch the transit of Mercury last November. Unfortunately, Mike died just a few weeks earlier, so we didn't get together. But you'll notice there's a space shuttle behind him, a model. Mike was one time the teacher of the year in Florida, where he lived, and he was the runner-up to Christy McAuliffe. Now, in a way, we could say lucky that she beat him out because he would have been on the shuttle, on the Challenger when it exploded. I'm kind of being facetious in that. It is the loss of Christy, it's very tragic. But Mike was quite a guy. Okay, here's my certificate for my asteroid, which was named for me in 2018. It was a surprise to me, other than I had given somebody my history a little bit and they passed it on. Okay, now there's the cover of my book. One of the things I like is I do talk about occultations in the book, is Springer, put the O coming out from behind the moon. The main part here is an antique moon map, and then a more modern drawing of the map of the moon. Okay, probably the first flight to the moon, or supposedly, legend says it happened about 2000 BC, but that's like 3,000 years before the Chinese invented gunpowder. So Van Gogh built a chair, had 47 gunpowder rockets, he had his servants light the rockets, and there was a big explosion, and he was gone. Now, did he fly up or was he killed? Anyway, they think that this really happened during the 16th century. But there's a lunar far side crater is named for him. So that's an interesting way of getting rockets. Well, we don't use gunpowder rockets. Anyway, probably the first known book was by Lucian of Samostrata, who flourished in the 2nd century, and he called it The True History. Now, what's really crazy is he never finished the book, so to speak, the story. He said, I'll tell you that in the next book, which because, he never wrote the next book that we know of. Anyway, he tells the people that they sailed out from what's now the Straits of Gibraltar, got sucked up to the moon by a vortex. And on the moon, there was a war between the kings of the sun and the moon over the colonization of Venus. And on the way home, now he served in the war with Endymion, who there's a lunar feature. And one of the funny things is that there were only men on the island, but they landed on, but that there were trees in the shape of women, and he lost a couple of his sailors trying to make love to the trees. Anyway, they got home and they were swallowed up by a 200-mile-long whale, and they escaped by building a bonfire inside the whale. So the story ends, like I said, before it was finished, but Lucian states that he will finish it in a second book, which becomes, why the whole thing was just such a fantasy. And you'll notice in the picture there is, since we're talking about Saturn, here's Saturn up in the picture. Okay. Now, The Man in the Moon, or Discourse on the Voyage Hither by Domingo Gonzalez, the Speedy Messenger, in 1638, by the British historian, who was actually an Anglican bishop, Francis Godwin, in 1638. Now, Speedy is flown to the moon by 10 geese, or swans up here in the top, that live on the moon, but they regularly migrate down to the Earth and back. He finds that the moon people are 28 feet tall, and women are more beautiful than on Earth. These people do not die, they simply disappear. The moon is paradise, but this is what I like, because there are no doctors or lawyers, and food grows everything. And this is where we get the term Speedy Gonzalez. Okay. Using dew, bottles of dew to fly to the moon. This is Cyrano de Bergerac, very famous drawing, which becomes the cosmic history of the states and empires of the moon by de Bergerac. He also had one really crazy idea in which the voyagers use a metal cart or stagecoach like thing, and they throw a large magnet up in the sky, and his metal car is pulled up under the magnet. Then he tosses the magnet higher until he reached the moon. Of course, he didn't think of when you let the magnet loose from his car, why it doesn't drop back down again. But you see there are little bottles all around his waist because they know dew rises. And so that was one, that he had the two methods that he was going to try to reach the moon. Now, this is a very rare story by Antonio Caputi. He's an Italian. This is the drawing from the front piece of the book. It's a poem, which should make David happy. Anyway, it's in English, it's the Ecstasy and Rapture Over the Moon by Archero Philoselino. Now, Seleno comes from the Greek name of Selene, or Selene, the goddess of the moon. Now, the World Catalog lists only 9 known copies. Actually, there's one more, happens to be in my library here. But he flew up to the moon on a cloud, as you can see in this issue. There were all kinds of ways of propulsion to get to the moon in those early days, whether it was birds or vortexes or storms and such, or like this being clouds. Now, in 1753, this does not have to do with moon travel per se, but there was a philosophical dream around the causes of rain, which had to do, there was an imaginary journey on a flying ship to the moon, where the author discusses the physical phenomena, the heat of the sun, on the lunar vapors that cause earthly rain, inspired by the book Voyage du Monde de Descartes from 1690, in which the Jesuit historian Gabriel Daniel wrote this, that it's the English title would be An Ingenious Satire on Descartes' System of Vortexes put into the form of a cosmic voyage through the Cartesian universe. And you see the sun up here at the top, heating the vapors from the moon, dropping down into Earth, filling these voids. kind of a weird system because they really didn't at that time understand, a lot of weather phenomena and stuff like that. But to think that the vapors on the moon caused our terrestrial rain. Now, this journey to the moon in 1811 by Reverend John Campbell, an Englishman, he flies to the moon on a cloud with a table with his little telescope. And when he's on the moon, he talks to the lunar inhabitants who want to know if the people on Earth know about God. And this is him flying over London down here at the bottom. Okay, during the 1600s and 1700s, there were many additional flights, fantasy flights to the moon, using birds, flying horses, mysteriously powered flying machines in which the author doesn't tell the propulsion. Almost like Jules Verne with the Nautilus. We now know it was probably atomic powered, but he doesn't say so anywhere in 20,000 Leagues Under the Sea. But one of the craziest one was the thought that everything you lose on Earth winds up going to the moon. And Kepler had come up with the idea in his book, his dream was that the moon was a way station to get to heaven, in which your soul stopped at the moon before it went on. Well, in this story, a friend goes up to get the lost wits for his friend, finds a jar with the guy's wits in it, and brings it back. Now, in the early 1800s, Lord John Russell anonymously wrote a book. We now know by comparing his handwriting, because he gave a presentation copy to a woman friend of his. And when I got the book, it still had a newspaper clipping in it and the woman's picture, and the handwriting had been checked. He finds numerous large, noisy warehouses filled with everything lost from the earth, including speeches. I like this one, wives tagging statements, memories, money, clothing, whatever you've lost goes up to the moon. Kind of a crazy idea. But all these warehouses, he entered and he hears all these voices and finally figures out what they were. Remember, he was a politician. He was the prime minister of England back in those days. Now, when the Montgolfiers invented balloons in the late 1700s, there was still the idea that there were people on the moon. And if you look closely here, where I'm pointing to, there are moon people, Selenites, looking and panicking over this balloon flight from the Earth. So down here is a French statement. This is from Camille Flammarion's book, Popular Astronomy in 1890. It says, "But fright is in the moon, where the onlookers and the ignorant judge the wandering balloon of the little common planet." I like that, the little common planet. So they were afraid that we would fly up to the moon in balloons, in which actually Edgar Allan Poe wrote a story about Hans Paul, who flies up to the moon in a hot air balloon. He wrote a sequel that was very similar to John Locke's book about Herschel, John Herschel, with his supposedly monstrous telescope, being able to see monsters and such on the moon, flying bat people and such. When Locke's famous moon hoax came out, Edgar Allan Poe destroyed the manuscript. So we don't know exactly what he had written about a return voyage to the moon. Now, Baron Munchkin, he wrote two stories, one in which he arrives at the moon on a boat, sails up. And if you look carefully, you can see with the clouds here, the lips of the moon, his eyes and nose. Now, another story he wrote, he throws a hatchet up in the air and it sticks to the moon. And he climbs up the rope in order to get his rope back. And he has a silver hatchet, and he's going to cut the rope and then fall back to Earth. In those days, they thought the moon was very close to the Earth because it's so small. Actually, the Greeks thought they could just reach up and touch the moon. And obviously, we know nowadays it's a little farther than just reaching. Okay. In 1865, Jules Verne came out with probably the most famous moon travel book, From the Earth to the Moon. 5 years later, he came out with Round the Moon. Now, this is a drawing from the American edition in 1895, but he never had a trail like a train cars. It was only the bullet-shaped object. In the first book, he reaches to the moon, but it's the second where they go around the moon and are able to come back later. Now, this is a knockoff of Jules Verne's. In Verne's book, they use a giant cannon to shoot the rocket up, where the three astronauts somehow survive the extreme G-forces and such. But in this story, they spend the unknown moon 2 years on the moon and this was his pen name, Peperi de Selenes, again, the Greek name for the using her name, in which the three adventurers use the equipment purchased from Jules Verne's story, the cannon and the bullet, and they go up to the moon where their story is that they go into Hadley Rill, where Apollo 15 landed, and they keep sinking down in, and finally they land where there are inhabitants, the Selenites. Now, this book preceded Morse code or radio, and so they set up lights on Mare Imbrium, giant lights, that when Imbrium's in the dark, they could signal back to Earth. And astronomers built a set of lights on Pikes Peak in Colorado to signal back. So they walk around the moon, excuse me, and on the far side, they find a Gothic church and abandoned village and such. And after 2 years, they want to come home. And so there's a volcano about to erupt. And so they put their spaceship in the volcano and are launched back to Earth. Well, this is a time when they still thought that the craters on the moon mostly were volcanic. It wasn't until Gene Shoemaker, in the 1960s, early 60s, found out that the craters on the moon were probably from impact, like meteor crater near Flagstaff. Okay, so this is just the cover, and you see their house and whatnot. So, playing with Verne's book, Georges Milland in 1902 produced a film called The Voyage dans la Lune, Trip to the Moon. This happened to be a very famous picture, and you notice on my shirt. It's the first movie with a plot. Prior to that, movies were of running horses and animals, and there's a very early movie of a couple guys striking an anvil, making a metal part. I'm very much into silent movies, and in Niles, we have a theater built in 1913 in which we show silent films in a building built as a Nickelodeon. Now, about the time of the movie, H.G. Wells produced his book, well-known, The First Men in the Moon. Now, they consider this the first science fiction work, but it kind of, I think it got predated by Jules Verne over 40 years earlier. In this case, there are two adventurers fly to the moon in a sphere using anti-gravity material, which they called corvrite. There's a businessman named Mr. Bedford who narrates the story. And there's Mr. Cavor, the inventor who invents the anti-gravity material. On the moon, they discovered it's inhabited by creatures they call selenites, which is also the name that Kepler used and many of the others. The men are captured by these bugs, and Mr. Bedford is able to escape. Now, the thing is that the selenites can't live in where it's light, so they're always in the dark. So he's able to escape. And now somehow Kelver now has a radio, and he's able to communicate with Earth, but the creatures don't allow him to return. Bedford did escape and is able to get back to Earth. So this is a copy of the first edition of the book. Now, there was a Polish, he was an alpinist, literary figure, nationalist, poet and philosopher and translator named Jerzy Zaleski. I think that's how you pronounce it. From 1902 to 1915, he created his science fiction book. Today, now there are three of them, known as the Lunar Trilogy. Now, he wrote in Polish. His books were translated into a couple Eastern European languages, but not German, English, or anything like that until last year. And so I was able to get 3 copies, but from the 1947. Now, there are 5 people, 4 men and a woman, who will go up to the moon and crash. One of them is killed. The others eventually all die. But the whole thing is that they figure on the far side of the moon, there's breathable air. Or why that was the story. And they finally travel, it's a travel log, to get to the far side where they survive. One of the men marries the woman. They have kids and more kids and their grandkids and on and on. In the third book, they're finally in the year 2700, and he's got there's now a whole village of people, but the moon people don't like the Earth moon people, and they try to kill them. There's a war going on and such. These books are new because, like I said, they were just translated into English last year. Willie Ley mentions them in a 1940 book. The one little line mentions the name, and I was able to find out the new books. This is not so much a book on traveling to the moon, fantasy flight. This would be if you're going to the moon and you need a travel guide by the Abbé Théophile Moreau in 1913. What's interesting is in those days, they still thought that all the moon peaks were sharp cones. This is what they thought the Alps looked like. Because when you have a shadow, a round ball, and you form a shadow, it's pointed, it's conical shape. So they thought that all of these mountains were conical shape. And this is the Earth up on top here. Okay. Oh, and that book is also translated into English. Now, this is kind of a funny one. This is a trip to Polaris, 264,000 trillion miles in an aeroplane. They're going to fly out in space in an open seated plane. This was produced, and it's another rare book by Charles Stoddard Muir in 1924. Now, the cellular cosmogony was by Cyrus Korish Tweed in late in the 1800s. They thought that this was the moon inside with being reflected by the sun, that the Earth was hollow and you could fly to the moon in just a few hours. Okay. Now they are still in Estero, Florida. You can visit there if you want. Their site is there. And they invented a device that would prove that the Earth curved up and not down. Okay, now this is a slide, so you see the pictures twice, the video slide, in which there are 8 maidens fly to the moon, and right over here is a prospector. So these were produced in 1895 by a company called the French Stereo Publishers in Lawrence, Kansas. And on the back is this written information about them. There's a set of 12 stereo cards. So these 8 little maidens fly up to the moon in a series for the little folks. So these are porcelain dolls flying to the moon with their wings. Now all this fantasy flight turned to reality. And we all know what happened in July 1969. This happens to be Neil Armstrong stepping down on the moon. Now, when I was selling real estate at one person's home, they had a great big painting of this, except by his foot was a crushed Oli beer can in the painting. So Neil signed over here in 1976, this block of 6. Now, just, do I still have a lot of time, or am I running out of time?
Yeah, we're kind of starting to run over at this point.
Okay, well, let me skip to the end then. I have one. Well, this actually is me and Galileo in the Galileo Museum in Florence. This finger-like thing is his middle finger on his right hand that one time was stolen and came back. And it's euphemistically called Galileo's last message to the Pope. Because, you know, it's the Pope that put him in prison, basically house arrest, for the last 10 years of his life. That's his monument inside Santa Croce. It was obviously set up for somebody else because, you know, the fresco doesn't quite fit the monument. And right across the hall there in the sanctuary is Michelangelo's crypt. I want to get.
Well, thank you very much, Robert. This was.
Let me get to the last one.
Sure.
So tonight, don't remember to brush your teeth with Zoe's, a cream for the teeth. So maybe I'll show those other postcards in another global meeting.
Sure.
That's it. So you can have it back. I'll stop sharing it. It's up to you. But thank you very much for even inviting me and allowing me to.
Well, you're invited back. So thank you. Thank you, Robert. That's awesome. Great. Okay. Well, up next is Jason Guenzel, The Vast Reaches. Jason's astrophotography is really amazing. It seems like each piece that he works on is just absolutely mind-blowing. I could stare at his images for hours and hours, and I have. So his images of the solar system, the sun, deep sky, everything is just, I often, you know, I just go, wow, how did he do that? You know, so, but they're beautiful, they're remarkable, and Jason always has good information about what he's presenting.
Well, thanks for having me, Scott. Can you hear me okay?
Thank you. Yep.
Yeah, it's always an honor to be here among this panel of guests because you always do a nice job putting them together.
Well, we feel like.
And oftentimes I feel a bit underprepared or almost like a poser when I come in here and I just got some images to share. But
I like it that way because it's really live. You know, I think if we came in too prepared, it would just be, it'd feel too polished or something. So it's hard to connect to the audience when you're kind of up on too much.
Yeah, don't sell yourself short, Jason. You take modest equipment. You take modest equipment and produce amazing images. And there's a few of us that have shown that you don't need super duper equipment to produce great images, and yours are a perfect example of that.
Yeah, well, thanks. I'll just walk through some of this. I've got I'll share my screen here, and we'll make sure that everything's coming through without a huge visual echo.
Yep, we see it.
All right.
There we
So you see my screen?
Yep.
All right. So the first thing I wanted to start off with here is just to show I'm going to talk a little bit about shooting planets, since the topic of this is the ringed planets, and namely Saturn. But I just wanted to show real quick of what a typical planetary imaging setup looks like. And this is the one I've been using lately. You can see it's set up here and imaging on a bright planet. I would think this image is a couple years old, and I think I'm on Jupiter there. And I bet that's probably Saturn off there to the left. But this is a 12-inch Newtonian telescope on top of a Skywatcher EQ6R mount. So zooming in here a little bit, you can see, the Newtonian telescope design has the focuser off here to the side of the diagonal. And I've got some extension tubes in here, and then I've got an image amplifier, which just magnifies that image. It's a TeleVue PowerMate, and that specific one I use amplifies the image 5x or more, depending on the spacing you have out from the telescope. So, from the PowerMate to the camera. So I'm running this one at about 6x. So it takes this telescope, which is a focal length of 1200 millimeters, and it blows that all the way up to about 7,000 millimeters is what it operates at.
Holy smokes. Okay.
And then this red thing at the end there is the camera. It's a ZWO ASI 183 mm. So it's a monochrome camera, takes images in black and white. So in front of that, there's a filter wheel, which I cycle through to get the luminance channel and then the red, green, and blue channels. And I have to take all those images once they're compiled and combine them together to get a full color image. So I just thought I'd show this before I start stepping through some of these images, because a lot of times there's questions on exactly how it's done.
Nice
and
to see the gear.
I encourage anybody, since I don't have a presentation that I'm going to walk through, if you have any questions, if anybody on the panel wants to interrupt me or anybody in the chat, just chime in, because I'm glad to answer questions. But the visual is probably the best demonstrator of what it takes to get an image like this. Equipment wise, the processing side is a whole nother ball game, and that's probably the longer journey. If you really dig into it, it's the processing and how you handle the images after you acquire them is a significant part of the game. Now, what I do here is I run this equipment, I run all the cables into a laptop, and I shoot videos of the planets. So I'll shoot thousands of frames, sometimes for the luminance channel, blocks of 10,000 frames a piece. And there's software available to grade and stack those images. And then the best, say, for example, 25% out of those thousands are stacked. And that's just essentially means that they're averaged together to remove random noise, and to, by stacking the highest quality frames, you're also removing the atmospheric blurring issues to some extent. And once you have a final stacked image, then that can go into your image processing software to get sharpened and the color applied and things like that. So a lot of time, I've had questions, from people asking me if they're renderings or drawings, and no, this is all photography. But there's a lot of, it's not necessarily wizardry, but it's a lot of mathematical operations going on in these images to improve the quality. And the quality degradation that we see is mostly just due to the atmosphere and the instability and the blurring that atmosphere creates when you're trying to image. And if there's any questions on that at the end, I can show a live representation of that.
Right. Now, you mentioned that this is a 12-inch Newtonian f5, is that right?
This is an f4 telescope.
F4, okay.
Yeah.
And you're running a Barlow, like a Teleview PowerMate or something like that?
Yeah, yeah. It's a 5x power mate.
5x, okay.
Yeah.
So really boosting the focal length, okay.
Right. And that, as you amplify an image with a Barlow, which is basically a lens which just zooms you in. It's like a zoom lens on a camera, except it's fixed. So once you put that thing in there, all of a sudden, anything you're looking at is blown up a lot. The drawback to that is it becomes dimmer. So that's where a large aperture telescope comes into play. And that's why large aperture telescopes are really sought after for planetary photography, is because to get short exposures to reduce the atmospheric blurring, and to get zoomed in, the image is very dim. And so the light gathering power of a large telescope really combats that. Makes sense?
Makes sense.
Yeah. All right. So now that I showed that telescope, I'll show this picture, which was not shot on that telescope, but this is actually a composite image where the central look at Saturn, and this is the Saturn system. So center look at Saturn was shot through that 12-inch telescope, but the remainder of the image was shot on an 8-inch SCT telescope at a lot shorter focal length. And the reason I did that is I wanted to capture all the moons of Saturn. And if I zoom in here on this image, there's a lot of background stars, but in red, I labeled all the moons of the Saturn system.
Oh, wow.
So moons are dim, and to get those properly exposed, you really need to expose for longer than you do on a bright planet like Saturn. So I think I was using 2-second exposures for the background image here, and I stacked, maybe a few hundred of those. But once you do that, the moons around the planet become revealed, and you can see that quite a number of these, although they're faint little dots, become visible. And really the magnitude on these is quite dim. And when you're trying to image those against a intensely bright planet like Saturn, a lot of it gets lost in the glare. So that's kind of what you're seeing around the planet Saturn is the inner moons get kind of washed out in that glare. What I really thought was interesting about this image, though, is if you zoom out, let me see if I can figure out how to do this again. So if you zoom out, I've got the moons labeled here in red. And if you look way, way over here, all the way into this corner, this is the planet Phoebe, and the moon Phoebe, very small moon of Saturn. And what really kind of shocked me on this is how far out this thing is. If you think, how far Saturn is from us, and then that moon being that far across the screen, really kind of surprised me. I just didn't think that a moon would be that far away. If you take a picture of Jupiter, you never see the main Galilean moons be that far away from the planet. So I thought that was quite interesting. So that's just a wide view of the Saturn system. Now we'll go in a little bit closer here to my best shot from this year of Saturn at opposition, which was taken just a few weeks ago. So this is the look on the night of opposition, and opposition is just when Saturn's opposite, or the sun and Saturn are on opposite sides of us from each other. So that's generally when we pass close by Saturn, and so we get the largest view of the year and also the brightest view of the year. And something kind of magical happens around opposition with Saturn is because the sun is directly behind us, the ice crystals in the rings reflect the sunlight directly back to us in a brighter fashion than they normally do, where you've got an angle of incidence where the reflection of the sun is elsewhere, but when the sun's right behind us, we get this really bright apparition of the rings, and that's kind of what's showcased here as the planet nears opposition. Just the rings kind of come alive, and they turn from their sort of yellowish color that they typically have into almost a blue reflective appearance.
Spectacular. Lots and lots of detail. There's a question for identifying the moons. Did you do any plate solving? Was there anything like that, or?
I use usually to locate moons, and I'll use planetarium software, and I like Sky Safari, which is there's several versions there, but you can dial in the date and time of your observation, and then you zoom in on the planet and you can see all the moons there. So it's easy to find. If I have an image that I took, I know what time I took it, I can use the planetarium software to kind of identify all the objects within there.
Right.
All right, so that is Saturn opposition. I may have shown this in the Global Star Party before, but I thought it's a cool little trick. And one of the things that modern computational tools and image processing software allows is transformations of the view, which means if you take an image and a software knows the geometric orientation of the planet, it can actually transform your image into an alternative view of that object. And that's what I did here with Saturn. This is a north polar projection of the planet. Whoop, not that close. So this is looking down on the North Pole of Saturn using my image. So it took my data and then translated the view into this top down, and it really shows off the size of the ring. I think it kind of gets lost when you're looking edge on like we do normally from Earth. You get really a vantage point of those rings being, essentially doubling the diameter of that system. And the cool thing about that software also and the data is that you get the shadow the planet throws back against the rings from the sunlight. And there's a little bit of a blend of artistic liberty in here where I've tried to make it look a little more realistic, as in I don't actually have data from behind the planet because I can't see it from here, but I've used the data I had to kind of fill in the shadows here to make it look a little bit more natural. Just thought that was a cool look. You don't see this kind of thing very often. So.
And what is the software that does this?
This was done in a software called WinJupos, which is a free software that is designed primarily, or initially it was designed to derotate images of Jupiter. In other words, if you took a sequence of images of Jupiter, because Jupiter rotates so fast, if they're all taken at different times, the planet's actually spinning while you're shooting. So it'll take those images and correct for that rotation and lay everything on top of each other. If you want to align color channels or detail luminance channels that you've captured, you can stack them that way. So I use that software a lot, but again, it allows for geometrical transformations or creations of maps. So you can do two-dimensional maps of these objects you're photographing, or you can do these polar looks. You can choose if you want to look at the top, bottom, what kind of polar projection or what kind of 2D map you want, and it can create all that stuff. Interesting software if you ever want to get into 3D rendering, because you can create these 2D maps, which you can then wrap onto 3D objects like spheres and do some 3D rendering with the images that you shoot, or NASA maps if you want to go that route.
Very interesting.
All right, so I had an idea for this presentation because I've been capturing Saturn now for 8 years. I think my first attempt was in 2014. Actually, I know it was. And one thing I did here is to kind of put all those images next to each other. So this was my first ever shot of Saturn with an 8-inch SCT in 2014. And I mean, you can be the judge, but I saw this and I went on a quest to try to improve my results, which came slowly at first. But if I step through these, you can kind of see. You'll actually see two things. You'll see the change in the appearance of the planet because the pole is tilted relative to us, and we get a different appearance of the rings through time. And you'll see that as I step through. But this was then 2015. You know, I'm starting to get my feet under me, understand what it takes. But you can see here the rings every year we're opening up a little bit more.
Yeah.
And now these weren't all taken during opposition, so you actually can see in here too the color of the rings changing depending on whether or not I was close to opposition when I shot this. And this image here was, let me move this banner. This was in 2017. And you can actually see it wasn't shot at opposition because during opposition, you don't actually see the shadow laying of the planet laying back on the rings because the sun is directly behind us. So there is no shadow visible. It's all hidden by the planet. So this was not shot at opposition.
Oh, these images are all gorgeous, though.
Yeah, and over time, then this is last year, and then this is this year. So I would say in the last couple of years, I've made some strides in improving the process. But
yeah, let's see your first image again, just for comparison.
Yeah.
Oh yeah.
Yeah.
Yeah. Amazing.
You know, the interesting thing to note here is it's not so much the equipment that changed here. I mean, it is a different telescope, but I would say it's in the same price class of telescope. It's really process and, you know, skill that's changed over time. And what I thought was really fun to do then is play this in the video form. You can see, I don't know if this is coming through in the video at all. Might be too fast of a frame rate. If it is, let me slow it down.
Oh, it is. We can see it. We can see the.
So now you can see the tilt changing over the years with all
Yeah.
these images combined from 2014 to this year. We saw the rings go from a fairly open position to full open and then back. And over the coming years, and I don't remember whose presentation it was that showed in 2025 in March, we're actually going to see these rings go full closed, which means they'll just be a thin line, likely not even visible, although I've never tried to image during a time like that. Well, we should get a very interesting
That's
look
very
at
cool. You know, a lot of astrophotographers never show their original first attempts, you know, so it's very impressive, though, to see the progression of your work.
Yeah, thanks. I mean, I like putting this together for that reason too. And one of the interesting things I see when I look at this playback at this speed is how much different the atmosphere looks every year. And even at the poles, you can see so the polar hex is more prominent some years. Some years there's a larger kind of almost a green cap on the top.
Yeah.
You know, I might not have the color balance perfect here, but there's definitely a changing appearance with time. But the main bands, like this orangish stripe here, and there's a brown green stripe here, these stay fairly consistent over the years.
Excellent.
All right. Any questions on that?
Not yet. No. I mean, people love your work, you know.
Yeah. Yeah, I see a comment there on the YouTube that my first Saturn is all yellow, and I will say that this planet in particular is, especially when you shoot in mono, getting the color balance proper is really difficult to understand what color the ring should be, because it actually changes during the opposition. So you always kind of, whenever I'm processing it, I have like an example image or a recent example image that I consider properly color balanced to try to use as a reference, but that's always a challenge. And yeah, a lot of times, especially if you're shooting with a one-shot color, camera, it looks a lot more yellow than when you're shooting with a monochrome camera. For some reason, that tends to accentuate the blues in the rings and the reds in the planet. All right, so one last thing. I know Jupiter is not a visibly ringed planet, but I shot this image a couple of weeks ago, and I thought it was my best look at Jupiter to date. This is with the same telescope. This is Jupiter and the moon Io, or Io, however you want to pronounce it. But this was probably my first instance where I could actually see details on the moon of Io, where you could see the slightly more brown poles and the more yellow mid latitudes of the moon. Io is, I guess, a couple quick facts. Io is about roughly the size of the moon. It's only 5% larger than our moon, and it's got two special facts associated with it. It's one of the most geologically active moons in our solar system. It's got over 400 known volcanoes on its surface, and it's got the least amount of water of any known object in our solar system. And it's continually ripped and torn by the gravitational pull of Jupiter because it's the innermost large moon. And that makes it the geologically active place. But because it's roughly the size of our moon, it gives you an immediate scale into a window into the scale of Jupiter. If you could imagine, this Jupiter being the same distance as our moon in the sky, and that's the size difference it would cover.
It's incredible.
Tremendous amount of sky.
I'm curious, Jason, do you think that with maybe a longer exposure or some sort of an occulting disk or something like that, do you think it would be possible for an amateur to photograph the rings of Jupiter?
I've thought a lot about that, especially today, seeing those images that were in Karim's presentation, right?
Right.
Yeah, I mean, they are visible, I know, more prominently in infrared. I have shot in infrared a lot. I shoot most of my luminance in the infrared channel. So is it possible? Maybe it is. I'm not sure, but I kind of want to try.
You want to try it? Yeah. Right. There's a question from Richard Lighthill. He wants to know why you're using an f4 scope rather than, say, like an f10.
I am using an f4 scope just for the aperture. Newtonians get unwieldy if they're longer focal length. You see 12-inch f5 isn't unreasonable, but you start talking about a 12-inch f7 or a 12-inch f10, and then you're talking about a huge
It's a 10-foot long tube.
The reason I'm using a Newtonian versus, say, an SCT, which is native f10, is just cost. I'm using a 12-inch Newtonian, which can be had for under $1,000, but you try to go out and get a 11-inch or 12-inch SCT, and you're talking about $3,000 or $4,000. So, I mean, that's mainly a cost thing. The way I make up for that is by using that power mate to give me the amplification of the image.
Plus, you know, a long focal length Newtonian like that. I used to own a 12-inch f10 optical Craftsman. Well, the store that I worked for owned it, and I was the one that bought it. That telescope was huge, had a huge mount, and a little tiny secondary is a joy to look through for planetary work. But yeah, it definitely would have been not an easy setup or takedown. As you know, our astronomy club did travel with it and stuff, but it was a beast.
Yeah, the 12-inch f4 is a beast. I can't imagine what
an f10
if it was f7 or f, you know, whatever.
Yeah,
but the Newtonians do offer some advantages and a lot of drawbacks, but one of the advantages is that the secondary obstruction is smaller than a comparably sized SCT. And so that just means that you're allowing more light to pass through the system. But as you step up in focal ratio, if you said f7 or f10, the secondary mirror does continue to get smaller or it can with the f ratios increasing. So it's not a bad idea to get a longer focal ratio Newtonian if planetary is the goal, but again, you got to be considerate of how much it weighs and how awkward it is. And the other thing is trying to hold collimation on a scope that's 8 feet long.
Right, there's flexure to deal with.
Right. Well, that's kind of all I had. So yeah, if there's any questions, let me know, and you can always find my work. I saw, Scott, you posted my link in there.
Yeah, for Instagram.
To find my stuff.
He's on Facebook as well. You can find him at the Vast Reaches. There was one other question for a rank beginner. Well, I don't know if this person's a rank beginner, but certainly a beginner astrophotographer. What software are you going to recommend?
For doing like planetary or deep sky. I mean,
let's choose planetary for now.
Yeah, for planetary, fortunately for users, there's a lot of freeware out there, or donationware if you choose to go that route. You can always donate to these people that spend their time developing the software. But for capture, I use Fire Capture, which just controls the camera and takes the videos, and that's free. And to stack, I use Auto Stackert, which is again a free or donationware software. And then when I get into sharpening and image work, I use PixInsight and Photoshop mainly.
So does PixInsight, it's got better wavelet processing than Registax? Is that that's why you use that?
I would say that the wavelet process which within PixInsight is pretty comparable.
Okay.
But there's other tools also that PixInsight offers. So it's kind of like, you're getting into the suite where you've got a lot more flexibility and options for detail or contrast enhancement. So, but wavelets Registax works fine. If you're just looking at software to sharpen, Registax works. And again, that's free. Or there's another one called IMPPG, which is mostly for solar imaging, or that was the focus of its development, but it's got a nice Lucy Richardson deconvolution routine in it, which you would get in PixInsight and some of those tools. But again, that's a free one you can grab if you want to go that route. But I tend to lean pretty heavily on PixInsight and Photoshop for the processing work.
Wonderful.
Thanks for
Wonderful.
having me
Thank you so
again,
much.
Scott. Yep.
Thanks for coming back on to Global Star Party, Jason.
Thank you.
It's awesome. Okay, so up next is
really nice, Jason. Great pictures.
Thank
yes.
you.
Up next is Adrian Bradley, who often treats us to amazing landscapes and nightscapes, and he never disappoints. And he wanes philosophically often about his feelings about the night sky and the peace that he finds there. So, Adrian, it's up to you.
All right. Well, thank you. Hopefully everyone can hear me. I vowed to go quick because I know we fell behind a little bit. I don't have too many images to share. And since the subject is on ring planets, visual observing, looking up at the night sky, you can see the ring planets. You can see them kind of moving through the years in the sky. And I figured I would just show in relation to where the Milky Way is, which is what I like to take pictures of all the time, where those planets are. So I will go ahead and share my screen. And as always, I just sort of present them in quick image format, similar to my good friend Maxie, who's on. So starting in, let's see, 2019, when I started doing this a lot, you've got Jupiter here and Saturn here. This was July. I still say this is a Perseid, but the direction that it's going makes it look more like an Aquariid because Aquarius over there. This was during the time when the Perseids, during the Perseid meteor shower. And then the year prior, I recall if Jupiter sat right there on this part of the dark nebula. I'm sure I have an image of it somewhere. I didn't prepare one where you could tell all Milky Way photos, you could tell the years they were taken by where the planet sat in relation to the Milky Way core. So that's your 2019. 2020, of course, meteors are easier to get at dark sites when you're taking these images. There's Jupiter, there's Saturn. And so just last year in 2020, the planets were close. And of course, they got close enough to where in the same field of view, you could see Saturn and Jupiter, you could see their moons as well. So this was as we were approaching that time period, that was the orientation. If you go outside now and try and take a look at where Jupiter and Saturn are, and you'll have to, the hole in these images due to the way I tried to process this image. So Jupiter has moved on. You see, Saturn hasn't moved much further. The core of the galaxies drop below horizon. Saturn's moved a little bit. And if you noticed, Saturn, because it's further away, how it doesn't move as much in the sky as Jupiter does. And you know, it was here, now it's here. And so it's moving in the night sky to where it's in a different location. This was a little earlier. And recently I went out to do some photography of the moon since it was there. This is an initial shot, and you can see they were all, the moon, Jupiter, and Saturn were all in a line.
Mm-hmm.
You can take your binoculars, you can take a telescope, and you've seen throughout this star party, you've seen all of the fine images of these planets. But if you're out there and you don't have any equipment and you just want to see, you see the night sky for what it is, you will notice the planets being brighter than most of the stars. Antares is over to the right now of the picture. Even with the moon out, you can see Jupiter, you can see Saturn. Now, if you process an image like this, there's Jupiter, there's Saturn. They kind of get lost in here with the stars. This is something that I noticed I may need to work on to try and differentiate those a little better. and then you've got the moon. So there, last night was an interesting alignment because the planets and the moon were in complete alignment. This is one of the places that I go to in Michigan. We've got a view of Lake Huron, and Karim, who's no longer with us on this show, he's with us, of course. He did the presentations on the ring planets. Over here somewhere in the Montreal province, Canada, is across this large lake, and you can see the light that the moon shines here. This is an image I took one night ago. One way to enjoy the night sky is to actively participate by seeing what it looks like, and if these clouds hold off, you can be surprised by what you see. And just looking up, even if you don't have equipment, seeing it for yourself is always you come back with memories. And until you get your camera going, it's always worth getting out. So yeah, and this is another image that I took. The ring planets are blocked by the tree, but when doing photography, you try a few different things. These are composite images where the moon is actually, the moon looks like this if we were able to see in as wide a field of view. Normally the moon seems a lot bigger. It seems a little bit more like this image when you're looking at it. It hangs in the sky. It looks a lot larger. The truth is the moon is actually even smaller if you wanted to put the real size of it. This was a reasonable compromise where it's not too big. You've got some imagers that'll make this moon huge and over exaggerate, whereas this is closer to what you actually see with your eyes. And again, the ring planets are so large they're visible all the way here on Earth, and they do move. So you can expect Jupiter, if we can go back to very first Milky Way picture, you can expect Jupiter to be well off the screen. It's close to Aquarius now, so it will be, I'm expecting it to be past Aquarius. Of course, if you get some software for your phone, Sky Safari, software that we've used to plot out where all stellar bodies, planets are going to be in the night sky, and you can use that to predict where, or you can move it ahead to see where it shows where the planets will be in a future date and time. And you can use your software to hold up to the you can hold your phone up to the night sky, and it tells you what you're looking at. And even if you don't see it in such a beautiful picture, you can always just think about the fact that you're looking at light from a planet that's so far away in our solar system. And so you are viewing Jupiter and Saturn directly, even though you're all the way back here on Earth. It takes the cameras and the imaging like Jason and many of the other imagers that we've got on to see what things look like. But again, like Scott says, I'm always philosophical. I guess that's kind of a part of who I am when it comes to the night sky. And we are part of what we're seeing out there. So keep looking up. And as always, when looking at the moon, you do not need special equipment. With the sun, you do. So please be careful. And with that, I am done with my presentation. That's it, Scott.
All right. Well, that was short and sweet, but thank you very much, Adrian. We always love seeing your most recent work. We're going to take a 10-minute break, and then we'll be back with more Global Star Party. We have Cesar Brollo from Buenos Aires, Nico the Hammer from Argentina, Chuck Allen with a special presentation, Maxi Falaris, also astrophotographer from Argentina, Jerry Hubble from the MSRO, and Cameron Gillis. So stay tuned, and we'll be right back.
Hi guys, really nice, Adrian. That was a really nice picture.
Thank you. Yeah, I've taken the nightscapes. I've tried doing classic astrophotography, and I'm planning on going to a star party in the Oklahoma, Texas star party. I'm planning on going and seeing what I can get in those really dark skies there. I'm sure I will overdo it, but hopefully
You sure? You should go.
Yeah, I will enjoy it, and all those photons hitting the cameras. I'll be bringing some equipment. I'll be doing some visual astronomy as well, and I'm going to give an attempt to image a couple of more obscure objects while I'm out there. See if I've got enough equipment to do it.
Yeah, that's for sure. When you are in a clear sky, it's a different sky. You can believe it.
Yeah, and also let's see, Veramus on the chat and Harold Locke, my friend online. Thank you all. Yeah, I hope to come to Argentina and eat some barbecue at Cesar and Maxi and Nicholas if you were there, and do some imaging. Probably a couple of years. We have to get through some of the scourge of this pandemic first, but then I've already warned the wife that I will be saving pennies because a trip will be coming.
Yeah, you will be very, very welcome.
Yeah, good. All right, time for my dinner. I'll keep watching on Facebook Live, and look forward to seeing you all's what you all have coming up on the second half.
Hey guys.
Oh, and Harold, before I go, yeah, I didn't use I didn't zoom in on it. I should have, but it was a composite because I took a direct shot of the moon and I placed it where the moon was in that actual, that view. I took a long look at it with my eyes and said, okay, this is how I want to capture it. And yeah, I was able to capture some detail on that moon. It was I've been tried to work on getting good detail of the moon and everything else around it because it can be tough.
Yeah, that is a really good picture when they showing the different exposures of the moon with the details and the stars and the dark side, the shadow.
Yeah,
I love that images.
Yeah, and it was I call it 3 full moons. You have the moon that appears full the most, but we know that it's still a waxing gibbous, but it's close. Yeah. You can see a shadow and it rises early. Then there's the moon the true full moon, which you typically see it at 99%. Sometimes you're lucky and you see the 100% full moon. Without it being an eclipse, but it has to be visible. It has to be visible in your hemisphere when it goes 100%.
Yeah, that's right. Just in time. You need to be right there.
Yeah, you have to be right there. And then that was the later moon that the moon that rises a little later. It's not quite full, but it's it's a full looking moon, but it's a waning gibbous. And my equipment, Cynthil asked the question that the equipment that I used was, I've been using a Sony A7 III, not the R3. The A7 III has fewer megapixels, is around 24. And I use a Sigma 14 to 24 millimeter lens, art lens. And to shoot the moon directly, I had my Canon 100 to 400 millimeter lens on a tripod with a tracker that I set at the moon speed. I roughly polar aligned it, and then I imaged the moon following it with a tracker. So I was able to use, and I forget the settings. I remember 1/80th of a second, which you can't handhold and shoot that very well, but
Yeah,
you can put that on a
right.
tripod. And I think I went ahead and went ISO 100. You can use ISO is, for, you amplify the signal. If you amplify it correctly, your noise is, you don't have as much noise as you think you might have. And,
Yeah,
but
right.
I went ahead and put it at ISO 100. And then, I believe I shot, focal length, F ratio. I don't know if it was F11. I could look it up, but that's how I got. So Cynthia, that's how I got those images. And beautiful location always helps, which is why I always go to those. I go near the giant Lake Huron. If you look up the lake to the east in Michigan, it looks like a thumb. I'm in that thumb area and I'm looking out over Lake Huron. That's where I do a lot of my imaging, just because of the beauty of it. So that's for Cynthia in the chat.
Yeah, great.
Yep. All righty, gentlemen. Look forward to seeing what you all have. Harold, yep, you do. I know you composite your images as well. Thank you, Cynthia. I always feel at peace when I'm out. It's a beautiful night and it's warmer too. So that's how I do it.
A clear sky night.
Clear sky nights are good, with or without the moon.
Exactly.
You just shoot depending on what's out there. All right. We'll talk with you all later.
Okay, Adrian. See you later.
See ya.
What's up, Cesar? ¿Qué onda?
¿Cómo está el team argentino? How are you?
Atendeme la remera de Nico.
Paso.
Is River Plate?
Yeah,
sure.
Yes. Yeah.
Go River Plate.
Go. Yes. Yes, it's typical. You choose 3 Argentinians.
It's the biggest
yes,
one.
Yeah.
There's no doubt.
Yes.
Cesar, I'm sending some clouds to you.
No, yes, I know, but I have the now I have a live view of Saturn, but in very very short focal. It's impossible to see. No, the idea is it's only to show the position of the satellites now. No more than this, because it's very small, the planet, to see in think that this is only a panoramic 80 millimeters.
Very short.
Yes, f7. Yes,
oh,
it's very short. Yes, normally I use Schmidt-Castle.
Yeah.
Yes. We are awaiting from Explorer Scientific Matsutov OTA, optical tube assembly of F15 with 5 inches diameter.
Call me when you receive it.
Yes, no problem. Yeah, yes, it's special. We import this especially for planets only.
Excellent.
Yeah. Yes, and I'm still using my EXOS 100 mount. It's the mount that I choose for my home.
For that gear, it goes very well. I see you put some another.
Yes, look the.
And we're back. So I hope you've been enjoying the 59th Global Star Party so far with our theme, the ring planets. So up next is Cesar Brollo from Buenos Aires, Argentina.
Hi, Scott.
Has his signature comments, and we love to have Cesar on our show. So he has shown us how to make the best use out of very small telescopes, small mounts, and to get into this hobby in a big way with a modest budget. So, Cesar, how's everything going down there in Buenos Aires?
Yes, I thank you to everyone, and it's a pleasure every Tuesday, every night that I share with this audience. This is a beautiful and wonderful audience that it's a real pleasure to share things of the sky, encouraging to the people to add into this this particular fabulous activity that is amateur astronomy. And well, tonight I have in a very small size Saturn. Let me check if I can share the screen. Yes. You can see that?
Yes.
Yes, we can see it.
Yeah, it's nice because it's a short focal, as like I told with Maxi 1 minute ago, that it's not a telescope thinking for planets. The camera is not thinking for the planets, but something that we can make with this kind of cameras is see not only the rings of the planets, if not put a little of sensibility to see the position of satellites.
Oh,
and
yeah.
Here you can see, yes. Here you can see.
Oh, look, there's one very close to the ring.
Yes.
Yes.
And you can see, sure, and you can see the different color of Titan. That is very interesting because it's really different to the rest of the planets. And all around the Saturn, the sky, this is, of course.
Oh, there's another one. Yeah.
Yeah.
There's two. Look, there's two binding.
Yes. And here you have 1, 2, 3, 4. And let me show you where is I need to change. You can see the stellarium, not because I need to change the. Yeah. Let me change the screen.
To see stellarium, you have to what I did to put it on window mode.
No. Yes. I
right
suffering in the first star parties of that we make. For us was a big mistake. Everyone that we trying to share the screen. Yes. No, you can see now. Okay, because I chose the screen of Stellarium, and we can compare. This is a very interesting exercise to the people to make. Let me check if I can. Okay.
There we go.
Let me see if the function. I don't know why. Okay, well, maybe here. Okay.
There we go.
Yes, this is that we saw. Sorry.
Cesar, I'm doing exactly the same thing you're doing right now at the MSRO, but Saturn's upside down.
Absolutely, yes. This is the problem.
We'll be able to see that when I show mine.
Sure. Look that you see Titan in this part and
Ione,
here,
Rhea.
yeah, yes.
Mm-hmm.
We can
Demas, Enceladus.
Yes. Let me
Titan.
check. Yes, we can see this and we can compare with the real picture. Oh, sorry. Okay. Okay. Now working again. Rhea, Diane, we can.
Pandora, Encelado, Tetis,
Yes,
Mimas.
yes.
Titan's the only moon known to have a dense atmosphere.
I go now to the real image again.
And the only other, I guess, object in our solar system which has surface liquid.
Mm-hmm.
Yes.
Methanol, right?
Mm-hmm.
Yes. Try with more digital zoom.
So it was discovered in 1655 by Dutch astronomer Christian Huygens. Titan was the first known moon of Saturn.
We can see 1, 2, 3. This is Titan and the bolts here. It's okay.
The camera does a great job of not blowing out Saturn, so you can see the moons really well.
Right.
Yes, the problem is that, well, here I using the only, yes, the camera is really sensitive.
It looks like it's much more sensitive than the one I'm using because your exposure times are very low.
Yes, sure. Well, here you have a lot of stars. If you, well, it's too much, but yes, because this is that the problem of this camera is advantage really because it's have a big pixel size. It's not for planetary use.
Oh, I see. Mm-hmm.
Yes, but you know, for some sensitive image, look, Jerry, I'm using Explorer. Every day my favorite reading thing is I really enjoy the forum of PMC8 because it's the best thing to read for the people that yes, you know, really enjoy it. Yesterday I started to use Stellarium, and I can use Stellarium in both modes from serial port from UDP. Yes, like
that's cool.
TSP, sorry, TSP. Yes, it's every time I'm going to use with more different programs, you know, and this is something that is great because anything that I try, sorry that I put my arm in the table and I move the telescope, sorry. And it's not the mount, it's me.
I'm glad to see you're using both the updated firmware that allows you to do the simultaneous connections. That's great to see that.
Yes, it's great. Yes, you never lost the connection, and I download the last firmware. It's great. It's great because it's a mount that this is a first time go-to mount for the people that isn't this maybe in a little more price that the Altazimuth mount comparing maybe a little more, but not a significant difference. You have the functions of a biggest mount in the market in a small one, and this is something that that I appreciate a lot, Sherry, your work in developing a lot of things about this, and I love to be a part of the open go-to community, because I love I was in 30 years, more than 30 years in this industry of telescopes, and I really I love it. Enjoy a lot of things that I can make with this my mount.
That's good. That's great.
Yeah.
That's good to hear.
Yeah. Yes. Well, here is Saturn.
That's yeah. So that's a new feature that I think it's new to the industry, is being able to control the mount with two different systems at the same time.
Yes, and something that I can found with the people that are the new owners of the mount here is that I never seen the people so how do you say compelling or going inside the things that you can make with the mount or the technology, and it's like another era, because the open go-to, the idea of for people that write code, and they open the eyes and say, really it's open source? Yes. I found that the people buy it like more like a new toy.
Right. Yeah.
Things. They say, okay, I like to make more things that only a closer software. If not, it's the idea of to be open is really great, because all this the idea of indie software, or it's a time where this is the way, maybe this is the idea.
Yes.
Well, I started to talk about Saturn and finished talking about technology, but this is.
And talk about the Mandalorian. This is the way.
This is the way. Yes, the Mandalorian. Yes, Star Wars. I know. Well, it's a pleasure to share Saturn and their moons with the audience.
Yes, we love it.
Sorry by the small size of the planet.
Oh, it's fine.
But something we can say that the people, especially for the first time amateurs, that they buy a telescope.
Yeah,
it's something educative when the people say, many times the people return the telescope that they buy to my store. They say, this telescope don't work because I see Saturn like a small, very small, tiny.
Yeah. I want to see a big screen like this.
They forget that it's almost 900 million miles away.
Yes, the problem, of course, that today, yes, absolutely, and this is how maybe with how many magnification, maybe 60 times, is how you can see Saturn, really teeny, shaky, and well, but now in this time where all people can make a picture of with their cell phone, the people is more happy because are going to make a really beautiful views of the planets. Well, of course, that Maxi and Nicolas and Jason and a lot of amateurs now are competing with the Hubble telescope, but not so many years ago, all that you can say that you can make with your telescope was only the very small size image. I was more as therapist to say to the people, no, it's okay. It's something that is real, but you can see something that is real and talking about, like you tell us that about the distance, about the come on, you're watching something that is really far away, but today is incredible because now it's possible to make the big size pictures better that many books that we can make in the maybe if you compare any books of pictures of planets in the 70s, Scott, maybe I don't have anyone that have a better picture of Maxi, Nicholas, of
Not
course,
from that time.
Jason. No, the pictures
that's right.
Are incredible. Are incredible.
It's incredible.
Absolutely.
Yeah, I would guess that the astronomers of that time would never guess that people would be using small backyard telescopes to make amazing images
absolutely
of the planets, and deep sky and all of this. They would just be, they would never guess it. It was so difficult in the film days to get great images.
Absolutely.
Certainly did it, but wow.
I share a little more of only to finish. Of course, that we can not compare some movement of satellites because I don't have a great a great point of view or but well, this is all. It's amazing. The teeny Saturn is how the people can see the first time with their telescope.
Yes, that's right. It's probably better. Probably the view that we're seeing now is better than the view Galileo had.
Probably, yes.
Right?
Definitely.
Well, remember that Galileo wrote three spheres, the big one in the center. He thought that Saturn don't have a ring, if not two small spheres at both sides. Maybe do you remember the sketch of Galileo? This is very interesting because it's
Then Cassini find out there was rings about around the planet.
Yes. I don't know, but of course that here, our planet, we can do it. A ring with the
satellites.
Satellite trash, space trash.
Like the science fiction planets, when you see some deep planet fictionary and see that ring is around because the junk and trash from in this case
Wally
it will
from
be
Disney. Yes, made a ring with the special trash.
Exactly.
Special shank. Yes. Well, this is all for tonight.
Okay. All right. Cesar.
Excellent, Cesar.
So are you making pizzas tonight, or is it not pizza?
Not tonight. I made pizzas last Saturday from the dough, of course, from everything. Absolutely, yeah.
I was telling my wife that in Argentina they like to barbecue and make pizzas for star parties. So I think
and also we eat pizza on breakfast.
For
maybe
breakfast.
the Sunday, yes, with Matt.
We cook the barbecue, right?
Yeah. you guys are
cold pizza. Cold pizza is always better in the morning.
Exactly.
Oh, yeah.
Exactly,
Absolutely, Jerry. Absolutely.
The cold beer.
Yes.
Huh?
Absolutely.
Cold beer, yeah, cold beer and a cold pizza in the morning.
Yes.
On Saturday morning, nothing but
nice combination.
Yes, this is something that.
Well, if you're an astronomer, it's dinner, right? I mean, you're waking.
Right.
Everybody else is waking up.
It's the end of your work day, so you're gonna have dinner. That's right.
That's right.
Yeah. Yes. Absolutely. Yes.
Okay. Okay. Well, up next, we're still down in Southern Hemisphere, and Nicholas Arias, Nico the Hammer, is joining us. And this is your second or third Global Star Party. Is that right, Nico?
Hi Scott, hi everyone. Yeah, this is my second time with the
Second time.
presentation.
Okay.
Yeah.
We're glad to have you.
I don't think
Maxie,
I've met. I
go
don't think
ahead.
I've met Nico
Yeah,
before,
Nico.
so it's good to meet you.
He has the nickname
Yeah,
of
the
Nico
same.
the Hammer because he's a drummer, you know?
Yeah,
So,
you remember.
a musician slash astronomer slash father, you know.
The art flows.
Yes, that's right.
What kind of
Okay.
music you listen, Nicholas?
Yeah,
Because when
I
you're a
like
drummer,
I play drums in a metal band, in a rock
wow.
metal band. Yeah.
Metal band. Oh wow. Okay.
Oh,
Mm-hmm.
A little
You have
strange.
to hit me strong.
Maybe for another night.
maybe you listen bands like Tool or bands that have a very strong drummers.
Yeah, that's right.
Mm-hmm. Yeah. We lost a drummer today. The Rolling Stones,
yes.
Charlie Watts. Yeah.
Absolutely, Charlie Watts.
Yeah.
Yes, 80 years.
I can see it in 2016 when they came to Argentina. I went with my two brothers, my sister-in-law and my cousin.
That's great.
And I remember when the show finished that he almost can walk. I remember I don't know who he was grabbing to in the scenario, but the amazing thing was he in almost 2 hours of concert, and it was the second of the third concert, he didn't lost the tempo to continue playing, you know. And
you suffer later playing.
And he has 75 years in that time. And I know also Nico knows that the drummer is the column and the structure of a band, because it goes with the tempo. If the drummers don't play good or miss some hit, will the band will lost, because he goes. Everyone follows the drummer. So that was amazing at that age, and to, I don't know, maybe 20,000 people in the scenario, or no more. It was a complete stadium in La Plata.
Yes.
Yeah, inspiring musician, you know. So.
Absolutely, a excellent jazz musician too. Not only for
yeah, that's great. That's great.
Okay, Nico.
Nico, it's all yours, man.
Yeah.
Sorry, Nico.
No, that's okay. Okay, tonight we are talking about the ringed planets, and I prepare a little presentation. Can you see it?
Yes.
Okay.
Astro Patio.
Yeah, my Astro Patio is my Astro backyard. Yeah. It was a nice combination. Okay, and as you know, the ring of Saturns, you have different rings and division, like Cassini division, the A ring and the B ring. That was the main rings that we can see. Even with a small capture, you can see the ring you see, it's those A and B rings. You have the Cassini division, that if you use a magnification and you have a good thing, you can perfectly see it. And you have the C ring, that is I think is really complex to capture in an image, but I will show you my captures with as you know, with my Dobson hand tracking. Well, I have a picture, because the rings are made of ice particles. And this is Saturn with my Dobson 3 nights ago. It's a video, so you can see how I
Beautiful
move it
image.
with
Yes.
my hand.
And hand tracking.
This is hand tracking with no motoring, and you will see the shake when I need to correct.
You have a pretty steady hand, though. That's good.
Yeah, this is my hand.
It's the hand of the drummer, you know.
Yep, and here again.
Precision, yeah.
And for each image of Saturn, with I work with a monochromatic camera, so I need to make 4 of these videos, 1 for each channel. So, well, you have the pre-processing. I use PIP for stabilization and align all the images.
Mm-hmm.
The auto stacker, that is also a free shareware to stack every video in one image, and I get the 4 channels: the light with no filter, the RGB channels, and the next step is to process every image of that 4. I use Astrosurface. It's like Registax. It's also free. But now I am using this. I'm liking the deconvolution.
What's the name of that again?
Astrosurface. I will put it in the chat. Yeah. Okay. And this is the channels, like stacking and process. Yeah, I really like the red channel. It's really detailed.
Yeah.
The green and blue, just to complain the color image, but the red one is the one who has all the details.
That's because the red channel filters out all the movement of the atmosphere. Really,
yeah,
it's really
right.
quiet in the red region, so that's why it's sharper.
That's right. The video I showed before is the red channel. It's the more stable image. And well, then I rotate and showing the 4 channels with wing hoopos. And this is what I get: the image of Saturn, and there is the C ring that I showed before in a heavy image. The Cassini division, the A and B, and this is one of the most nice pictures I get. Is with all the moons in the compositions. For the size of the sensor, I cannot get on this special picture Titan. It was like up there, but there is a lot of moons, and I really like that kind of photography.
Excellent work. It's very impressive that you do all this with the Dobsonian with no motors.
It's really fun. It's really entertaining.
Amazing.
Yeah,
it's amazing,
Nico,
really.
Nico de Maciza.
Yeah, thanks.
Well, that just proves where there's a will, there's a way.
Right.
Yeah, and well, as a bonus track, this is brand new because I just find out a few hours ago that I have registered in the WDS catalog my first double star.
Hey,
capturing with my Dobson.
Bravo, Nico.
Muy buena, Nico. Excellent.
So it was these captures and all the nights. I was 30 nights. It was in between February and March, and I was waiting since June, see if they check it out the info, and it was all okay, and no survey registered before. So this is my first dose, and I'm so happy.
That's great. Wonderful.
Yeah, thanks.
Wonderful.
Excellent, man. Congratulations.
Thank you. Oh, that was my little presentation for tonight.
Thank you very
Scott,
much. Nico.
thanks everyone.
Genius. Excellent.
Okay. Well, up next is Chuck Allen, back from the, he was on earlier doing the Astronomical League door prizes. Chuck, are you still with us?
I'm right here.
All right, great.
Sorry, I was listening to everybody, but I'm trying to get door prize stuff out. So I've got about 40 emails to write and
Oh my God. Yeah, you
draft
guys have
letters to
so
attach.
many door prizes for the Astronomical League convention. It's got to be a record.
It was $9,500 worth. Yeah.
Incredible.
So the clubs really came through, but now I've got to get the prize winners information to the club so they can send the stuff on. And
Right.
so I've been typing and listening and peeking in on some images as well. I'm sorry I didn't stay. Let me pick up on some stuff that Karim was talking about earlier. Maybe this time I can actually get the slideshow to work the first time. Yeah, except that's not the slide I want.
There we go.
Oh, hang on, I'm going to go back. Okay, let's try this. All right. I give up. Okay, I'm just going to run back to the beginning here. We'll start here with Haumea. You remember that Karim mentioned that one of our dwarf planets, Haumea, actually has been found to have rings. Now, Haumea was discovered in 2003 when it basically eclipsed a star called Urat 533-182543, a very interesting name, obviously. It's the third largest of the TNOs, the trans-Neptunian objects. It has about 1/3 the mass of Pluto. It's seen here, very ellipsoidal, as you can see. Visible in 20-inch Dobbs easily, or smaller even, magnitude 17.3, but it's a hard find, as you can imagine, with the number of background stars. It was seen by New Horizons on the way to Pluto, by the way. New Horizons did a lot of work en route to Pluto, and this was one of the things it was after. Haumea has two moons, Hi'iaka and Namaka, and here you can see them in motion. And at this particular point, we were almost in the plane of the orbits of the two moons themselves. The moons are, the Hi'iaka is about 195 miles in diameter. It orbits at about 31,000 miles from the dwarf planet. Namaka is about 105 miles in diameter and orbits about half that far away. The surface brightness of Haumea is extremely high, very high albedo. Has the same albedo as snow, crystalline ice snow. And it does have a sort of a red area that are thought to be tholins, perhaps similar to the red area we found on Charon in the New Horizons mission. It's believed, though, that Haumea's surface has been resurfaced recently because it's obviously subject to a lot of cosmic rays and direct ultraviolet radiation that would cause the crystalline ice in the surface to become amorphous ice, disorganized and a little bit darker than Haumea appears. It has a very rapid rotation, also about 3.9 hours. But first, let me show you the orbit. This is a very confusing diagram. Haumea is the blue circle right here. So as you can see, it's orbiting close to the orbit of Uranus at some points between basically Saturn and Uranus. And it's got an inclined orbit. The rotation is about 3.9 hours. This is the fastest rotating body over 100 kilometers in size in the entire solar system. And in 2017, the Haumea system occulted a star, and as a result, a ring system was discovered. And the ring system has a radius from the center of about 1,400 miles, and that puts it about basically 438 miles from the ends of Haumea out to the ring system themselves. The width of the rings is about 43 miles, and they actually contribute 5% of the brightness of Haumea. So they're very significant rings in that sense. This is a collisional moon. Haumea and its two moons, Hi'iaka and Namaka, are thought to be the results of a collision. And so the particles that are in these rings are thought to be rock with some water ice mixed in. Pluto, of course, was suspected of having rings, but the New Horizons mission looked back after passing Pluto and found no evidence of rings there. These particles are close to being in 1-3 resonance with this rotation, which means that for every 3 rotations of Haumea, the particles in the rings rotate approximately once, but not quite. They're just a little bit out of resonance, and that makes astronomers believe that these rings are a little bit eccentric in terms of their orientation around Haumea. There are no current plans to explore Haumea. The next possible flybys would be launched in 2026 or in 2037, and the flight time to Haumea would be 14 to 16 years if a mission was generated to get there. You heard Karim also mention Kuriklu. Kuriklu is a centaur, as he said, and it was discovered at Kitt Peak in 1997. It shines with quotes at magnitude 18.3 and has dimensions of about, in miles, 125 by 164 by 183. So it too is a little irregular. It's the largest of the centaurs. The centaurs orbit beyond Neptune and have unstable orbits, which means that their future is either to be slung out of the solar system, to crash into planets in the interior, or to crash into the sun, or to become short period comets. And they orbit between Saturn and Uranus as well, many of them down in this range in here. This particular Kuriklu orbits every 63 years. And in 2014, this is the orbit, the green out here is the orbit of Uranus. Saturn is the yellow orbit. Back, you can see it rises, it's eccentric. It rises above, it's above the plane and then drops below the plane. Mm-hmm. And is also highly elliptical in its orbit. Well, anyway, there was a ring discovery made in 2014, again, because the rings occulted a star. It's found to have 2 rings, Oyapuki, which is about 4.3 miles wide, and Chuy, which is about 2 miles wide. These are named after rivers on the north and southern boundaries of Brazil. They're about 6 miles apart, these 2 rings, and they're roughly 80 miles above the surface of Kuriklu. Mm-hmm. The rings explain some dimming that was seen in Kuriklu back in 2008. At that point, the rings were edge on and were occluding part of Kuriklu from our view here on Earth. And this ring system discovery from the occultation explains why that dimming was observed. These rings are thought to consist of water ice that has migrated from the surface of Kuriklu out to the ring system.
It's surprising that that's such low gravity that the ring would be stable.
It's funny because my next sentence was going to be that it was found to be very surprising that such small bodies could have rings.
Oh,
So
yeah.
it's a very valid point that was coming out of my mouth next. It is therefore thought, and I think Karim alluded to this, that these rings will disperse certainly within the next million years, unless again, and I think Karim even mentioned this, unless there are shepherd moons that would help keep these rings in place. And that could extend their life, as of course they have the rings of Saturn. The Kuriklu itself rotates every 7 hours, and it's thought that that process of rapid rotation cleared out the particles that are inside this range, inside the rings. Karim also alluded to 2060 Chiron, or 96P Chiron. It has 2 designations because Chiron actually has a possibility of being designated as 3 different things. It's a possible dwarf planet, 120 miles in diameter. It's also classified as a minor planet, a centaur, and it's also because of something that happened in the late 80s and early 90s, now deemed to be a comet, designated 96P. What happened in 1988, it brightened suddenly and developed a coma, and then about 2 years or 3 years later in 1993 developed a small tail. And so it's thought to be both a comet and a minor planet, Centaur, at this point. Here's another image of it taken by the Hubble Space Telescope, highly pixelized, obviously. Its orbit takes it just beyond the perihelion of Uranus and just inside the orbit of Saturn. And back in 720 AD, it came within 30 million miles of Saturn, which is the closest approach in recent history. It's thought to be a refugee from the Kuiper Belt, likely to become a short period comet in the next million years or so. The rings of this system, here's another image of the orbit seen in purple. Okay, the Chiron was found to have rings, again, because of the stellar occultation. And that too explains some variations in brightness that have been noted in Chiron over the years. These rings are also thought to be water ice. The radius of the rings is about 204 miles from the center of the planet, or about 140 miles above the surface of Chiron. They're very sharply defined rings, unlike the rings around the previous bodies. There are 2 missions planned to explore Chiron. One is the Chiron Orbiter mission that is supposed to launch sometime between 2023 and 2025. There's also a discovery program, Centaurus, which is supposed to do a flyby of Chiron, and the launch date for that is projected to be 2030. As Karim also mentioned, there have been ring systems discovered in exoplanets. One of them is PDS 110b, orbiting a star in Orion, about 420 light years distance. The wide-angle search for planets, or WASP, found an unusual feature. It found a haze around the star PD 110. And when closer studies were made, the results sat on the desk in 2008 of a grad student by the name of Hugh Osborne at the University of Warwick. And about 3 years later, another study of PDS 110 was performed at the kilo degree extremely little telescope, which is a fascinating term. I'd love to know how small it is and whether it will fit in my den. And it's called KELT. And 800 days later, this study found the same thing. And so the two got together, comparing notes, and they found that the star was going through 25-day periods of dimming. And it was found that that it had this large gas giant planet orbiting PDS 110 called B, had a ring system about 30 million miles across. That's about 200 times wider than the rings of Saturn. And the next possible opportunity for studying these rings, in other words, the next time when these rings were expected to occult the star, PDS 110 itself, was 2017. Unfortunately, and this is an image of PDS 110, unfortunately, nothing was seen in 2017. So there's some possibility that rather than being a ring system, this could be a cocoon of some sort around planet B of the system. And finally, there's J1407, that's the star, and its planet designated B, and Centaurus, 434 light years away. This is a gas giant planet, and it's thought to have a very complex ring system. And the planet itself is in a 10-year orbit around the star. This was observed in 2012 and can't be glimpsed again until the at that time, they knew it could not be glimpsed again until around 2020, which was last year. Unfortunately, 2020 came, the observations were performed, and nothing was seen. But it's thought that the planet's orbit might be more eccentric than had previously been thought, which would mean the ring system might not have occulted the star. The expectation is that this ring system, seen here in comparison with the planet's distance from the star, this distance is 4 astronomical units. That's 4/5 the distance between the sun and Jupiter, and this is the size of the ring system in comparison. Yeah, it's an
It's a
immense.
huge disk.
It's a huge disk, to be sure. So those are the known ring systems, and that leaves us with 9 worlds with rings, 4 planets, dwarf planet Haumea, 2 centaurs, Chiron and Chariklu, and 2 exoplanets, PDS 110b and J 1407b. So pardon me for repeating some of the introductory remarks that Karim made, but I thought I would just expand on these a little bit. Thank you.
Thank you
That's
very much.
amazing.
Okay. Up next is Maxi Folares. Maxi came to he's been to several global star parties by now, maybe 10?
I think it was in May when I came the first time, and I don't know. I think I lost only one because I couldn't be, but I tried to be every Thursday. Today I was remember a scene from The Simpsons when Bart saw to Homer and say, why so elegant? Because today is the GSP.
Oh. Well, yeah, you have developed a rhythm, so that's good. And you've been a great contributor. Maxi showed us how to take really amazing celestial photos with just his smartphone. And he even modified his smartphone, pulling out the lenses so that he could image directly onto the sensor. So very cool stuff. Of course, Maxi has some other cameras as well, but he always makes, he's like squeezing out every last drop of performance out of his equipment, and he produces spectacular results. Maxi, I'll turn it over to you, man.
Well, thank you for the presentation, Scott. And good night, everyone. I hope you're fine. And Nico, congratulations again for that discovery, because I know you from I don't know 2 years ago, and you start with study doubles. I don't know, maybe only 1 year ago, maybe less.
Maybe.
And you discover a double star. That's an amazing and a huge point to amateur astronomers. So with a few equipment, that's all, and perseverance and continuing and study and everything. So again, congratulations, man.
Thank you, Max. I like to encourage all the amateurs. There is always something that you can do and bring some new thing to science. So go on, Max.
Thank you, Nico. Well, tonight I wanted to show some work that I did, because the idea was to be outside, but unfortunately we had some bad weather, only some clouds that doesn't allow to me to be outside and show you the sky of my city. So I think I will be pretty shortly, and let me show you my screen.
Sure.
Okay. So do you see it?
Yes, we do.
Okay. Let me show you. This is the file. Well, first of all, the last Friday, I received some package that I buy from China, and I was, well, Nico, you know my expectations.
Months waiting for that camera.
Yes, and I remember, I think the last GSP, I say to all of you, it was in Alaska, and then 2 days before that came to Argentina. I remember woke up 4 a.m. because I couldn't sleep that night, and see the tips. Sorry, the schedule of the package, and says it comes out from Santiago de Chile, from UPS, and there was almost 30 minutes before that, and I remember the page of Flight Radar. Is a free page that you can see all the airplanes where you are, and remember see that plane coming to Buenos Aires and passing through over my house, maybe 10 kilometers from me. And I remember I went outside and hear that airplane. So came this thing that I have here. Is a color cool camera.
Congratulations, Max.
Thank you. This is an all I several years I was waiting for this grab, because I think this will allow to me to be more professionally of my amateur side. And of course, I always encourage to everyone to start with of what you have with you, and there's no excuses. Then when you see that that's all what you get, always you want more, that's the time when you have to change what you're doing. But that knowledge you can spare to everyone to invite and be an amateur astrophotographer. And well, the last Sunday I was prepared to, well, I of course do the correctly collimation, and I start to check out that camera with some stars in Scorpio. This is zoom. I don't know, Scott, what do you think about the collimation?
Can you zoom in?
Do you see it?
It looks pretty good. Looks pretty good. There might be a little bit of drift, but in the image, let's look at one corner versus the other corner.
Right here, right?
Maybe.
Also, I have some coma. I figured it out that.
Yeah, sure, of course.
By in the 4F telescope is a problem, but well, I do some, in this case, some stack images. I think it was 30 seconds, also in Scorpio. Let me see if I can get some. This is a capture that I did and share with my friends in WhatsApp about that night. It was a very horrible night because it was a lot of fog, mist, moonlight, wind. No, there was horrible, but I want to put it on the computer and see if it works and how we see it. And well, this is the Cat's Paw Nebula. It's only 30 seconds of exposure. It's like I say, it wasn't a good night. And this is M83.
Okay. Yeah.
This was 30 seconds. No, 1 minute, I think, without guiding. But and in this time I have very almost 40 degrees and have a lot of light pollution and everything, but it goes okay. And this was Summon. Well, this is the jewel box cluster in
Very
the
nice.
Southern Cross.
Very nice.
And also, of course, in that night, I have the moon rising behind me, and I'm pointed because I want to see how FOV I have with this camera and my telescope, and figure it out. It was a full moon. I had some. The sensor is very square. Is 3,000 for 3,000. The size of the sensor pixels, and well, it's all the moon and some dark space. And also I wanted to practice in planetary captures with this deep sky camera, because the size of the pixel is the same that the regularly planetary camera, and also the QHY camera that I have. So then I went to Omega Centauri. It perfectly fits. And this is some Saturn that I was practice with fire capture in the size of Roy 320 and 240 size of pixel, and two Barlows, 2x and 2x Barlows, with an F4 telescope. I can have this, this is only one single frame, but I was able to capture almost 222 frames per second. So that's a lot of.
You need a new hard drive now.
You know, it's only an SSD hard drive, and almost only have 128 gigabytes. And when I start to do only one single video, this goes 10 gigabytes less. So there's only for maybe 4 and 5 videos to continue. So
yeah, it's very easy to use up. I know, even close up on the moon, you can use up 30 gigabytes a night easily. With just an hour's worth of video. I mean, it's not even an hour's worth of video. It's just, you know, it's very quick to use up disk space.
A few minutes.
A few minutes. Almost 1 minute, only 1 minute. I was capturing in this case. Well, it's 90 seconds, 1.5 minutes. And I remember I get some 10,000, almost 12,000 frames.
Wow.
It's a lot. And this is, of course, a dedicated camera for deep sky images. But when you get ROI, it was like the same space and see it like a QHY, but a lot of frames to get. So also this is the camera, the 533, and this is an adapter to get a Nikon lens with, and to put some IR UV filter or something like that. And this is a capture because I was only able to see the the light of the well, it wasn't in this door, but I get more exposure and I upload all the gain, and it wasn't very shiny. It's like it was very dark also. And well, this is the pictures that I did that night. This is Jupiter. I, in this case, did 5 videos, and they rotated and try to get more sharpness. And there are some storms. Well, like I said, that night the jet stream, it was 50 or 60. It was very.
It was terrible for planetary.
No, very bad, very bad. And you know, for that case, and to get this kind of details in that night, I think I was very lucky. And this was a very single detail of Saturn. It's not like the same like yours, Nico. You have more powerful equipment.
Different nights.
And different nights, of course.
Yeah.
But also, like I always say, there's the capture there, and there is the pre-processing, and every one of us process in a different way. So sometimes it goes to the good way, or sometimes it goes to the wrong way. And there is no bad way, because you are doing
the only bad way
astrophotography.
is not doing.
Exactly. Yes. So this is what I did in these days. Unfortunately, like I said, I want to do some live images, but unfortunately, this is a satellitial map of Argentina. I'm here in the provincia de Buenos Aires, and this is the city of Buenos Aires, and I'm here. So all that clouds came by this night, so I wasn't able to share with you some captures. I hope the next week maybe I can do it. So thank you, everyone. This is a little presentation. I'm very glad to have this camera to continue and get more professionally. And remember, if you have any doubts, or you say, oh no, I don't know anything, maybe this is not mine. No, try it. Only try it. If you don't try it, you will not able to get nothing. So try it. If you like it, continue. If you're not, that's okay. So thank you and good night, everyone. Scott, I can hear you.
We can hear you, Scott.
Hold on. I said thank you, Maxi, and I said that you're giving the same advice that Jerry Hubble loves to give as well, and that's just try it, see what happens. So you can read so many reviews or so many tips or whatever, and I think you can overthink it sometimes, and you just gotta start digging in and actually seeing what does work and what doesn't work. So, but now we're going to turn to Jerry Hubble, who's working from remotely into the Mark Slade Remote Observatory. And Jerry, you said you had Saturn up earlier?
Yeah, it's still up. I've been tracking it for the last 2 or 3 hours, actually.
Nice.
This is going to look very similar to what Cesar showed us, because I'm using sharp cap,
Upside down.
and it's upside down though, right?
It's upside down.
So let me go
There,
ahead and share.
For Maxie and Cesar, it's upside down.
I want to share a couple other things first, though. I'm going to share my whole screen, so that it makes it easier for me to step between the different pictures.
Okay.
Let's see. So this is, you see that?
Yeah.
So this is a full disk moon. I call them full disk moon images that I take with the Astro camera on the Mark Slade Remote Observatory 165 refractor that we have, the Explore Scientific APO. It's got a focal length that we're using at 851 millimeters. Okay. And I'm taking these are with the deep sky camera. So I just want to show you the example of what we can see with this system. All right. So I'm going to start zooming in here. So I'm going to zoom into Copernicus. Now see this? Look how nice and sharp this is. So we can see craters down to like 2 miles.
Wow, that's pretty good.
And then I really love this part here. Let me see if I can find it here. Okay, here. This is a straight wall. Right there.
Yeah.
A little sliver is pretty cool. This is a third quarter moon. So this is early in the morning when I took this. Like 3 o'clock or something in the morning. I got up, and then if you can see some of the detail we get there's Clavius. But just, you don't always have to have the longest focal length and the fastest cameras in terms of video to take great high resolution images. I consider this high resolution because it's pushing the performance of the system to the highest performance it can go. So that in that term, it's going to be high resolution for that system.
Sure.
So let me bring up, let me see what else I've got here. All right. So it's going to pop up a bunch of pictures down here. This is pictures of Saturn, Jupiter, and Mars that we took on one night. Again, with the 165 and a 2x Barlow. And this is the kind of resolution we get with the deep sky camera.
Mm-hmm.
And that was the first time I ever took pictures of all 3 planets in one evening. And you can see they're about a couple hours apart, an hour and a half between each of these images, which I thought that was pretty cool.
This is all at the same focal length, or
well, that was with a 2x Barlow, so that was probably around 1600 millimeter focal length.
Yeah.
Now I'm going to go to another camera system. What was this? Let me zoom up a little bit here. This was, I don't know if I got the date and time on here anywhere. I'm not sure when this was taken, in 2018, but this is some pictures of the moon that I took with a video camera on it's on the 165. But you can see I'm using a program called Lunar Terminator Visualization Tool to measure these peaks.
Mm-hmm.
So
that's amazing.
So using the shadows and the time and date and the solar, the geometry of the system, you can calculate how high the peaks are above the.
And how high is that peak?
That's 2,000 meters.
2,000 meters.
Whoa.
Yep. So that's 2 kilometers, and then you look here. Now this is in relation to this spot where the shadow hits the peak. The peak shadow extends out here. You can see the relief of the peak right here, how it's shaped like this. Same thing here. And so the sun direction is what that red line is. That's where the sun is coming from. And it projects it out and tells you, okay, this is where the shadow hits. So this is where it crosses the peak. That's where the shadow line is. That's where it crosses the peak, and this is how it calculates. And then it calculates the height of the peak.
Mm-hmm.
That's 2.5 kilometers, and that's 1.8 kilometers. So that's Theophilus. Is what that crater is. But you get an idea of how small some of these
Getting
craters
down
are.
to- you're
It's
getting
like 1.5 to 1
resolution to
kilometer.
1
Yeah,
mile.
right,
Yes.
1 mile. So that's pretty good.
Amazing.
A really
let's see.
nice resolution, Sherry.
Yeah, right.
You used to observe the craters and you forgot how big are they. It's amazing.
Yeah, that's right. Let me see. Oh, here's another one, another full disk image that I marked up and zoomed up on different things. So these two craters are about 6 miles in diameter. This one is 3 miles in diameter. Okay. So this was one of my ones I took this was in 2019. I took this image. And then you can see the straight wall. Here's another aspect of the straight wall. This is a first, this is getting on towards the third quarter. But you can see Thebit D, that crater's 3 miles. It's not quite as high resolution as my other images were. In fact, this other one that I showed first was the highest resolution full disk image I'd ever taken last year. Let's see. I think that's all I want to show here. Oh, I wanted to do a shout out to these guys.
Oh yeah.
This is during the great solar eclipse of 2017
Casper.
in Casper, Wyoming.
Yeah.
And that's Robert Reeves on the right and Rick Hill on the left. And then that's the first time I met these guys. It's pretty cool. Robert gave me one of his images there that he had printed out. He was handing out. So I got one of his lunar images and I got to meet these guys. I'd met Robert before, but first time I met Rick was then. That was kind of cool.
Both really nice guys. All three really nice guys.
That's
right.
That's right. What else do I have here? Oh, this is one other thing you can do with the Lunar Terminator visualization tool. So does this look a little odd? This doesn't look like a normal last quarter moon, does it? That's because I've mapped the image to a sphere and rotated it around to where you're over top of Mare Crisium. So it's like you're in a spaceship flying over top of Mare Crisium, and then you see this right here. If you recognize, this is what I always recognize as a woman's face on the moon right here. This is her hair, this is her eyeball, this is her her chin's down here. So this is rotated around about 60 or 70 degrees towards the left, what the moon would look like if you were flying over this, if you were over top of this location on the moon. It's kind of cool. So that's one of the tools that you can use to change the perspective and the way things look. And you can see the image only goes this far around the edge of the moon because it's been rotated around. Well, let me stop and let me share the live image of Saturn that I have on the observatory. Let's see here.
Today was the anniversary of the first images of NASA taken in the orbit of the moon. I think it was the 55 years anniversary.
Yep. So if you look here, you can see the observatory. Let me just show you where we're at. So this is the inside. You can see, and I can show you a picture of what it actually looks like in a minute. But you can see the telescope pointing out through the slit of the dome. And this is the first picture I took of Saturn with the deep sky camera, just a still, and it was I don't remember what the exposure was, but you can see Titan there, and then the other moons that were there in this picture. But then that's the chart that I'm using, Carte de Ciel. And Here's Saturn live,
Okay.
just like Cesar was showing. And let me zoom up a
Yeah,
little
it's
bit
upside
more.
down though, right?
It's upside down. That's right.
You just put it in vertical, so you have
Yes,
probably
That's right. So I wanted to share that. It's pretty low. I noticed that Cesar's telescope was pointed near straight up. So that's where from his point of view, that's where Saturn was in the sky. But from my point of view, it's pretty low in the sky. It's like at 30 degrees altitude. So it just passed the meridian 12 minutes ago. So I've got the mount tracking past the meridian right now. I didn't want
I
to flip it
see.
around to continue to take images. So are there any questions about the MSRO on that regard? I'm going to show another picture of it. I'm going to stop my share and start it again. Let's see. Yeah. There's what it looks like.
Right.
And it's not quite as cleaned up as some people's. They train their wires and they make them nice and neat. At this point in time, we were changing instruments out and doing other things. And even today, it kind of looks like that. The wires are a little better trained than what they are there, but we're not overly concerned about that as long as it can doesn't snag. The wires don't snag on anything. We rotate it around, we test it to make sure it doesn't snag and pull things. So you can see that they're pretty loose. That way they don't pull tight
Have you
when
guys
we're
had
moving around.
much trouble with that, or?
No, we really haven't. It's kind of a habit. I don't know if it's a good habit or not, but we haven't, early on, we were really doing a lot of work on the system. We'd change the camera out, change the cables, do a couple things, move things around. And, but that's what we're doing. That's the way our system looks right now.
I guess when you get it all set, you really don't want to mess with it too much.
No, we don't. And it's remote and it's remotely operated. So I don't visit the observatory very often, maybe once or twice a month, not that much. And it's pretty much always available for us.
Excellent. Well, thanks, Jerry. Thank you very much.
Sure.
Yeah. Up next is Cameron Gillis, who's been running a series of programs with us on Wednesdays called Camstronomy. Cameron, are you there?
Yes. Hey, sorry for that. This was getting the mute. This was finding the mute button. I've been listening intently.
For sure.
Well, let me first of all say, just a great appreciation and recognition of all the work and not work, the effort and the enthusiasm and the amount of time that everyone has put into this Global Star Party. I mean, you look at all the presentations; they're top notch. And to your point earlier, Scott, I mean, these are not like canned, podium type of presentations. It's not like a seminar.
Yeah.
It's really, people are putting this through from. You can see it's from the love of the hobby and the love of astronomy, and the quality but it takes a lot of time, and it just shows the enthusiasm and the depth of all the contributors. I mean, especially people like Karim and obviously David and David. I mean, it's just incredible. I mean, these guys are obviously seasoned veterans that have done a lot of publications and that, and but it's not a. It shows the depth and the amount of time and wealth that they have spent in this beautiful hobby. So it's really nice to be part of that. So I'm just doing my 2 cents here on the astronomy survey. So let me share my screen. And let me go. Okay, so before we get into the astronomy survey, kind of update for this week, I just wanted to share a few pictures of Saturn. I have only got into, as many of you know, I've only recently got into imaging, very recently. I mean, last year I started with smartphone a little bit, and that's what I'm going to be showing you, a couple of smartphone pictures of Saturn. So here's my very first picture of Saturn. So, you know, this is, it has the rings, and you can see, you can actually see Cassini's division. So I'm happy, you know. That was my very first one. I think I took this through a Mac 102, and I kind of zoomed in. Then I took another picture here. Let me just move this out of the way here. A little bit later, and this is with my Note 20, a little higher resolution camera, smartphone still. And these are just snaps. There's no processing, no nothing. So I'm just happy. You can see the shadow. You can see Cassini's division a little better, and you can actually see some of the belts here. But again, when your first impression is like, yeah, it's a mushy picture, but I'm kind of like what Jerry is talking about, the kind of scientific. What kind of features can you get out of it? The data doesn't have to be necessarily a pretty picture. It's just it. I mean, if you show this to Galileo or Copernicus or any of those guys, man, like you said earlier, Scott, what we can do in our backyard with the technology at our fingertips, it's wonderful, and
Right,
it's really incredible.
Yes.
So,
as Dave Eicher has said many times, we're living in the golden age of astronomy, and he's right.
Oh, absolutely, absolutely, and to be able to just do this self-discovery, it really helps improve everyone's consciousness, right? I mean, we when we get together in these star parties, we really are all, even though we have a very diverse background of experience, and that because of this capabilities, we're able to really be on the same page and in the same mindset very quickly, and be able to relate to all this, which is fantastic. Here's another. I showed this one last week. The main reason why I want to highlight this is I actually caught the moon of Titan. This is definitely not a Jason Guenzel image, but you know, I got it in there at the edge, and it's like when I overexposed it, so that was kind of cool. And then this is my latest picture. So you know, sometimes you have to go backwards before you go forwards again. So this is with remember my earlier pictures were all with my smartphone. And smartphone has a very good fast CCD or CMOS. It's a CMOS as well. I would have to correct myself. So everything's CMOS now, but it's a much faster processor chip on there. So this is with my ASI 294. It's like a point. My first imaging with an dedicated astronomy camera. But the point is, this is the first, and then the future, when I get all set up properly, and I start to use Wenju pose or you know, some of the stacking and lucky imaging, all that kind of cool stuff. This will get better, but I just wanted to share with everyone my very first astro imaging camera, and also contrast that to what I was my very first smartphone camera pictures. Like you can, this is quite a bit better, and that was with, you know, because of the smartphone is actually better adapted right off the bat. And if there's no substitute, and then I just want to share a visual observation. Last night, we had one of the few clear nights here in Seattle. And as mentioned earlier, both Saturn and Jupiter are in beautiful position. Still low on the horizon. I'm at 47 degrees north, so it's still quite low. I think Jupiter is about 20 or so degrees off the horizon, which is, you know, if you tell that to Christopher Go, he'll be like, what? You have to be at least 60 degrees off the horizon, you know. And of course, he's in the Philippines, so that's no problem. But anyhow, but the point is, visually, think about it. Our own eyes, there is no substitute. We have in our brains and our eyes, we have lucky imaging, we have stacking, we have everything live with your eye. And when you see, there's no substitute. It's very difficult to replicate that with a picture. That experience, to see it live. You all the little jiggling and, you know, the atmospheric disturbance and all that, it still has sharp, steady moments of steady seeing. You can filter through that, and the brain can pick out so much detail, and it's such a pleasing experience to see. So I pumped up the power. I stuck in my Nagler zoom and on my 8-inch, and wow, and I saw festoons in Jupiter as well, and even many of the belts or many of the bands in Saturn, and multiple. I think I even saw the ankle ring division in Saturn. I mean, it's just really nice. Very difficult to capture image, but I just wanted to describe that a little bit, and share. It's nice to do both imaging, of course, to capture it and share, but also. And what Jerry showed earlier with the live video, I think what's going to happen is we're going to get better and better with the technology, where when Jerry in the future shows this, we're going to be able to show what closer to what the eye can see. It's going to start to do more image processing and more lucky imaging and filtering out the seeing. So you're going to get really good quality pictures that are going to be live in the future. I see that happening.
That is definitely what the trend is building more processing power inside the camera to do internal stacking and filtering and sharpening type stuff, like you said.
Yes, right on, Jerry. Yeah, that's really cool. And that's So I see more and more pre-processing, and we're going to be able to enjoy and study and analyze the pictures rather than a lot of post-processing work. So that will make it much easier. There'll still be post-processing, but you can do different types of post-processing than more higher level stuff. So this is anyhow. So now let's switch over, and I'll go into my sky survey. So if you recall, last week we were finishing up in Vulpecula. We did 3 constellations. We did Delphinus. We're going up through the Milky Way here, Sagitta and Vulpecula. We ended up with the Dumbbell Nebula as the last, right over here, with the last object. And now we're going to dive into Cygnus. So Cygnus has about 30 or so of what I call best and brightest objects. There's many, of course, but in my sky survey, in my observations, I've categorized 30 objects that are worthy of note, if you will. And now I'm going through. I've already captured all the images, and if I go to my catalog here, everything that's grayed out, it means that I've already optimized it and processed it and compressed it and everything. So if you look at Cygnus, I have basically all these pictures here already ready to go. So I'm getting a heads up, and I'm going to go through probably 10, I think, remind me, Scott, I have about a half an hour tomorrow, right? Because I think we start at 6 for mine, right? With my schedule.
We are going to start at 6 o'clock, and at 7 o'clock we have Caitlin Ahrens with 7 months of science.
Great. I might have to cut mine short though to like half an hour, because I have another thing. But I'll be able to work it. But the point is, I'm going to split up Cygnus into several weeks because there's about 30 objects that I want to go through, and we'll on the average takes us about half an hour to explore 10 objects. So and that seems to be a good pace as we're going through. But the point is, I have many images. I took a whole boatload of images, and lots of different stages. So I'll be sharing those. And just to give you a preview of future, probably not tomorrow, but in the future, the latest thing I got here is Cygnus. Let me go to the Veil Nebula. Here we go. Yeah. So here's I took 2 mosaics, because remember my field of view in my 8-inch Cassegrain with a f6.3 reducer is not quite large enough. The Veil Nebula is quite large. If I turn on the let me just turn on the my eyepiece here. So evolution, or is it ASI 294 with 6.3? What's down here?
These are overlays, or?
These are overlays. Here we go. Yeah, this is the one. I was looking at future cameras. I want to get a full frame 4/3 sensor, or not 4/3. I want to get a, what do they call it? The large, the full frame sensor. But those are pretty pricey. So that will be in the future. I'm learning the techniques right now so that when I do get a really awesome camera, I'm gonna get the most out of it. So so here's my view. So if there's a little bit of a delay, bear with me. So here's the frame. If I zoom in, so you can see.
Oh yeah, it's big.
It's pretty big. But if I get now this is with my f6.3 reducer on my 2000, so that makes it 1280 millimeter focal length. But if I change that to an ED80, which is coming in eventually. Here we go, 294. If I overlay that, look at that. So the ED80 is going to give me the whole Eastern night very comfortably. And I can even get some more stuff in it. So not bad. But if I want to go even more, then just to show you in the future, that's with my current camera. If I go even more, so a full frame, let's go for this 6200. Or no, the 2400 is pretty good. Here you can read the degrees. This is good. Yeah, this is good. So ED80, look at that. With this big one here, that's beautiful. The size of that with an ED80, and this is why you want small scopes. It's really efficient. You can get you can get an entire Beale Nebula complex with that, but you need to spend a lot of money. I think these cameras are like, $2,500 or whatever like that. They're not cheap, but you get what you get out of that is a 4.3 degree by 2.88 degree field of view, right? Which is really slick. Anyhow, so now getting back to the sky survey. So this is just an example of what I'm able to do right now. And the other thing that's coming, I am so happy to say, and Scott, this is awesome, is I just got my Exos 2 and Jerry, Exos 2.
Oh, it just arrived?
With PMC8.
Oh, wow.
I tell you, it's a beautiful machine, and it is really awesome. And I can't wait to take it through its paces. But I can tell you this: when you're moving into equatorial, and it's not an overnight thing. You want to build up to it. It's something that when you start to, there's a lot of things you need to understand to be able to get the most out of it. And what's just nice, because with the PMC8 and the Exos 2, it also grows, right? It's an open system, so that I'm really excited about many years of future development with this. But for now, I can't wait, and it's going to take me some time because as you know, I've optimized my imaging with an altazimuth right now. That's this system here. But this is quite a bit different. The image train the same. I literally took my tube and my image train. That's identical. That stays the same. Cable management. Jerry was showing the cable. I'm the same as Jerry. When you're changing things, you can make it nice. The most important is you don't get cord wrap, and you want to make sure that things are long enough and not getting tied up. So that's what I'm working on right now, making sure everything's good so I don't get any snags. And then with all the imaging cables, that is, and the power cables that go with that. And then basically, just getting it optimized, getting it connected, and then figuring out polar alignment in a very efficient way. It's going to take me some time. And but yeah, I am. You will see this starting to be folded into the Astronomy Sky Survey. And the biggest advantage is, let me show you again. This is with GoTo, so with an altazimuth. So right now, I look at today, in the West Coast here, it's still only 9:12 in the evening. See, zenith is over here. Now you can see as I move, this is an go-to altazimuth. And you can see as I get above about 60 degrees, it becomes basically, you get field rotation, you get all sorts of problems. But as soon as you go to equatorial, which I just go to settings here, and we go to equatorial coordinates, and I think that's all I need to do, I believe. Yeah, here we go. Now you can see, oh, and I have to get rid of that just a minute, and I have to change the mount type just a minute. Go down here. Yeah, let's change this to equatorial. No, German equatorial. There we go. So once you do that, see what happens? Now, all those juicy objects that are directly overhead, like the Milky Way, I'm looking at it right now. I took all those images, as you saw earlier, of Cygnus when it was about 60 degrees north off the, well, below 60 degrees off the horizon as it was rising from the east, which you have to do with an altazimuth. But then I can't take advantage of the thinner atmosphere, you know, the lower light pollution, because it's, you know, you have less dispersion, all those beautiful benefits. So now with my new equatorial mount, my you know, XS2 PMC8, I can actually go directly overhead, and I can't wait. And I'm going to start to do some new fresh image, and no more field rotation, so I can take like 1 minute and longer. I was limited to 30 seconds with an Altaz, and still pretty decent pictures. But you can imagine how fun it's going to be when I get this system. But the workflow is really important. So I'm an engineer, so you know, I like to do things you know, in an organized way. But of course, when I first get it, I try to break it, and I try to do lots of different things, and I'm having fun with that right now. But I can tell you that I will continue to communicate as I go on this journey and share my new adventures with my new mount. So to be continued. So for tomorrow, just to wrap up, we're going into Cygnus, and I'm saying probably about 10 objects in Cygnus on the southern part. So that's my update for today. So thank you.
Okay, Cameron, thank you very much. Thank you.
Excellent, man.
So
that's nice, Cam.
Yeah, I would say people are starting to wind down in our chat. They're going to, some are going to bed, and you know, how do you guys feel? Do you want to continue, or do you want to call it a night?
Let's do some kind of after party and think then
Okay.
we're done.
Okay. All right. Okay. So let's take about a 10-minute break, and we'll be back. Okay.
All right.
Okay.
All right.
Yeah, thanks.
Thanks.
How you doing, Maxi?
How you doing, man?
All right. Good to see you again. Oops, I dropped my mouse. So yeah, no, this is I'm really excited, I'll tell you. It's a beautiful mount. It's pretty serious. I mean, this Exos 2 is much bigger. You know, you see it and that, but when you have it, it's a hefty mount. It's what I mean by that is I can definitely put a lot of load on it. I see why people put stuff on it. It's pretty rock solid. So I'm excited. Hey, Cesar.
Hey, Cesar, you came back.
Yes,
right.
yes. No, I'm escaped from the here the backyard in my in my place, in my building. It's a tower. I live in a tower.
Yes.
You know, with a pool. Yes, in Buenos Aires. And I choose. I found today. I found a place near to the pool that is great for to have more open skies, like from my balcony. And I found it you know, a connection for electricity, and because well, I'm happy because it's a great place. I don't need to go to the rooftop you know, to give the keys is a nightmare. The rooftop is okay, but this place is only it's only a few steps from here.
Yes, yes. Yeah. What floor are you on, Cesar? In your apartment?
Only 3, and this the tree.
Yes.
The tree is the first, really, because it's a, you know, it's a high
commercial and stuff, right? You have commercial below.
No, it's a big, you know, it's a big lobby, empty, with chairs and, you know, but very high.
Yes, yes.
It's
in Palermo, right?
Yes. Maxi, when you came from to Palermo, advise me, of course, Nico too. We can make a small star party in here.
Yeah.
Of course, that you, Cameron.
Of course, you come here to Chivilcoy.
No, of course, yes. In Chivilcoy, I bring the asado, of course. Yes.
Now,
I bring the chorizos.
Nico, where are you in relation to Cesar and Maxi? So Maxi's to the southwest of Cesar, right? You're southwest of Buenos Aires, right, Maxi?
Yes,
almost the west.
Almost west, okay.
The west.
And
yes.
how about you, Nico?
I'm on the south of the out
metropolitan area.
The city of Buenos Aires. That's right. We maybe 15 kilometers at least.
Yes,
close by.
It's the same like the south, like New Jersey is for New York, for example, comparing something that it's. I am from very near. I'm from the town very near, closely to the town of Nico. Nico is from Banfield, and I am from Remedios de Escalada. And this is only not Nico, that we have Uriarte Street, like a limit.
I'm 10 blocks from there.
Yes.
This is the map, Cameron, to take a look. This is Buenos Aires, the city of Buenos Aires. The rest of the part is the Great Buenos Aires, or the conurbano, the metropolitan area. Nico is from Cesar is from here in the city of Buenos Aires.
Yes.
Nico, well, here's Lomas de Zamora. It's right here, right, Nico?
No, in Lomas de Zamora. In Lomas de Zamora.
In Lomas de Zamora.
In the north of Lomas de Zamora.
Okay. From this area.
Nico, explain to Maxi.
Maxi only knows how to
we have
because the GPS.
Special blocks, a special neighborhood, right?
Yes, it's something that is people from Zona Sur. We have a lot of shows about our place, of course, because it's like in any area of big cities, and of course that, for example, for me, my classmates make a lot of shows to me and another people from Remedios de Escalada, because Remedios de Escalada is the oldest town in the area, made by the people that came from England and made the rain, the rails, all about the trains.
Oh, the train, yes,
yes. Banfield too. Banfield
is a name in English.
Yes.
Banfield.
Yes, it's a lot of south. A lot of our south of Buenos Aires towns have towns from Buenos Aires metropolitan area. Especially in the south, we have a lot of names in English because it
was the British
made from the British, the time of the rail, the trains,
Exactly.
We, for example, in Remedios de Escalada, Nico knows this, that is the only town in the south that is crossing all the towns are mostly in like a square.
Oh yeah,
in this
Jefferson,
position.
that's amazing.
And yeah, oh, Chivilcoy, the big city of Chivilcoy.
Oh, the Perla del Oeste, the shiny ball of the West.
Yeah.
Oh wow, that's a very interesting grid. That is very interesting. So they don't they have north, south, east, west in a diamond shape. That is interesting.
Yeah, yes. It's mostly of the towns in the Buenos Aires in Argentina really have the idea of Spanish foundation of you know, the main plaza, the main plaza with the church. Yes. And this is
La
interesting.
Plata.
But this is interesting because La Plata was thinking in 1875, I think, and was designed entirely with the idea to make a city outside Buenos Aires to be the major city in Provincia de Buenos Aires. That is different. Is the capital of
It's the capital of the province of
the
Buenos
state
Aires.
or the province of Buenos Aires.
This is the province of Buenos Aires. All of this.
Okay.
La Plata is the capital of the province, but Buenos Aires is a federal district. It's the capital of the country.
It's like Washington in United States.
Exactly.
Yes, yes. That makes sense. That's like in Canada. You have Toronto and Ottawa, right?
Exactly.
You both on Ontario and Quebec, and then you have Ottawa is actually the main capital. You have the country. Yes, yes.
Something that is interesting is how you can see, Maxi, you can put the image a little smaller, where you can see like points, the towns in province of Buenos Aires, here. You can have a grid, like a grid, because you have in the first time this was by the rail, the
rail trains.
Yes, it's interesting because it's like a grid. It's very interesting. Lincoln, Junín, Pergamino. Yeah.
Here in Chivilcoy, we have this is the Route 5, but parallel is the rail train, and here is where almost 100 years ago came the train only to this area, because they coming to get granos de maíz, the corn and soil, crops and everything, because this is the farm area. And here comes to the station of train. This is very old station of train, but in this part, this is today is a place you can go run or walk, and when you continuing, you get this place. This is the omnibus or the bus station in Chivilcoy, because this was the old northern station to the well, here's in the city there are too many silos where the people get save the storage the
grain
crops.
elevators,
the seeds.
Here's another one, and here's beside it, because that's why that train come to Chivilcoy and then goes to Buenos Aires to Once. Here, Palmanera to this place, the 11 station.
Wow, that's a big
Cameron,
city.
now you are ready to come to Buenos Aires. You know everything.
Yeah, you know everything.
Yes. Yeah.
Oh, you know what I really appreciate is you guys know all the little nuggets, right? All the little spaces that are really special, right? What makes national treasure. I mean, there's a lot of very special places I can see. Would be wonderful. Yeah,
Yeah,
that's
that's
really
right.
cool.
We used to travel sometimes with the telescope or with our families, and in every little town you stop, there is a little of special thing or a lot of history. It's really nice.
Wow. Oh, that's nice. I can see that, and also quite old buildings, right? I mean, like what are the
Yes.
typical villages? How old are the buildings typically?
Well, here are almost 150 years because, for example, this. Let me show you some streets of Chivilcoy.
Yeah. Yes.
Well, it's very Italian way.
Oh wow.
Nice.
This is
That's really nice.
The
wow, it's like
Conservatory
the
of Music.
1900s. The early 1900s, 19th century beginning or 18th, end of the 18th.
This is
a
supermarket, but if you continuing, well, this is an old pizzeria.
Of course.
Cantina, Don Pedrin,
Don Pedrin.
it calls. And in front of this place, this is the Spanish theater, founded in
1887. Yes.
Exactly. Wow. And look the building.
Yeah.
Here's
the shutters and everything.
The Spanish Association.
Wow. Yes.
And look at this place. It's very, very old. Well, this is Cheers. It's a pub to get some beer.
What makes it really also nice is, think about it. They were preserved from the wars, right? All the wars in Europe, right? Destroyed a lot of the buildings. So you kept a lot of that untouched, right? And this is all original. Very nice. Wow.
Yeah.
Beautiful.
Well, this is Chivilcoy. It's very Italian, Spanish, and some French culture.
Very international.
This is the main square in Chivilcoy. Here is four manzanas, ¿cómo se dice?
Blocks.
Four blocks. This is the Banco Nación, the Nation Bank. Well, let me see if.
So Harold Locke wants to know. I want to know: do your wives drag you away from the telescope to go out to bars and or do tango?
No. No. In that case, no.
Can't get away from the telescope. Yeah, that's right.
If it is cloudy, maybe.
Yeah.
Yeah, but what a beautiful country,
Yeah.
Really.
Thank you.
We have a lot of space here. But this is a small town. This is I don't know.
With wide avenues, like all
very
cities
clean
in
and
Buenos Aires,
nice.
very clean. Yes,
Yeah,
all towns.
Yes.
But especially Chivilcoy, because Max is from Chivilcoy, are clean, are beautiful. The people really care their own towns.
Yes,
they're nice. I really appreciate the towns, the cities in Provincia of Buenos Aires, because it's nice. And it's nice when you go to another city or when you go to another place. I love go inside the city and eat inside the towns, because if you eat something in the in the gas station, you have all the same foods, and when you turn to the right or left and go inside the town, this is something that I made in the United States in Scott, that I remember that I enjoyed a lot, that when I went to the Peach State Staircase, I rented a house in Key Largo, and
okay,
with I rented a car, I had a rented car.
Sure.
Some people told me, no, you need to take a flight to go to Atlanta, Georgia. I say, how many? Do you remember the story? Maybe.
Yeah,
Said,
yeah.
how many miles are?
It's a long drive. It is.
Sure, it's a long drive, but people from many, Cameron, from Canada, you, Scott, or Maxi, or Nicolas, we need all time to go to places where you need to drive the entire day. In Argentina, the roads are not so all tollways or double lane roads, but we found something like normal to go 1,000 kilometers in one day.
Yeah.
Yes, when the people told me, okay, you can drive, but it's maybe an entire day from Key Largo, not Key Largo. Yes, Key Largo. Was in Key Largo.
Yeah, Key Largo is kind of north.
Yes, yes, sure. The one road.
Yeah.
And we have a trouble with a key of the car. When we started the trip at 10 a.m. Very, very late, late to go to Atlanta. But really, we enjoyed a lot. Wow, it's beautiful.
This is a project.
The old and the new one.
Exactly, from my city. This is. Do you remember the market that I show? Well, this is the same place. It is at the exactly. And
yes, I know that.
They painted the statue different color.
Yeah.
Well, here's the whole of the city.
Wow. And they restored it too.
No, this is when they started to put stones in the
street,
the field, in the street.
Yeah, the paving stones. Yes.
Because it was only dirt. So this is the place, still very antiquated, but it still has the same almost 100 years.
Yeah.
That's
really cool. Really neat.
This is a very good project. This is the middle of the square, the principal square, the same font. Well, this is an accident that happened in that time. There is the city hall again, the church. Always have the same.
Good pictures. Good comparison. Yeah. Where did you dig this up? Are you a tour guide on the side?
Look at this avenue. This is very dirty avenue, and now this is what it looks like.
Looks like today. Wow.
Yeah,
that's really good.
I love the.
Yeah, before and after.
Yeah.
This is well, this was the bus station, the old one. Now it's a place to go to play paddle. Well, this is the old Metropolitan Cinema, or was the old theater, the hospital. This is a school.
Similar.
The
this is a
national school in 1939. Well, this is the normal school. It has the same build. It looks like the same.
Wow, identical. Yeah.
Yes, it's incredible.
Look at obviously this was a fire.
Fire truck, yeah, or fire wagon. Fire wagon.
An old one. Yeah. In 100 years ago.
Yes.
This is the same place. Cheers, the association, Spanish association. This is the same place. No, it's amazing to see this. I grew up here, and see these pictures makes me think that a lot of people passing by, and a lot of things changed, but some things still the same.
Yes.
So,
yes.
This is the project photography of Chivilcoy yesterday and today. This is something that I want to show.
Oh, I love that. That's awesome.
Very
interesting. That is, and that goes to, for everything. I mean, I love the before and after, and the same with obviously astronomy pictures, right? I mean, looking at the Hubble plates, right? And then looking at the today's plates, right? And then looking at what we can do with a smartphone.
That's right.
And what you showed, those before and after of the city, it kind of reminds me of that too, right? Just with everything we do as humans, you see some things that are the same, that hasn't changed, but then other things are significant changes, right? But it's really, I love that. I love the continuity. Now that we have that ability to record and document everything, it's so fun to see that. Yeah, that's really cool. Thanks for sharing. That's really cool, Maxi. Love it. And it just makes me really. I'm looking forward to coming down there sometime.
You should. It's a beautiful city, Chivilcoy.
Really nice. Yeah.
Very, very quietly, obviously we have too many people. It's some kind of huge city, but a Saturday at the afternoon is very quietly. The Sunday at the morning, you hear the birds, maybe some chicken from a neighborhood that has some little farm animals, but it's very, very peaceful.
And you have a nice sky.
Also, yes.
Yeah. What's the? Yeah, that was what I was going to ask next about the light pollution. How is it down there?
Well, in Chivilcoy, it's almost 6 and 7 because they are changing to
Let me cry. 6 and 7.
But if you do some maybe 50 miles to the north, to the west, or to the south, you change to a border 3.
Yeah,
maybe
in less than one hour. In the car or less, yes.
Yes, maybe 10 minutes from Chivilcoy. You have. It's incredible. Yes.
Nice, really nice. That's
so
great.
You can maybe rent a farm or make a permission to an owner to be there, because of course there are people that store animals, and it's a very huge place. There are policemen from a rural policeman, but sometimes there are some people that have guns, and if you are, what are you doing taking pictures in the middle of the night, in the middle of the rural road? What the heck? So
the dark makes eating a masita with the telescope.
Yes, the masita. Very good, Nicolas.
Exactly.
Yes. People from Chivilcoy have the masita in one hand, the telescope, and they are happy.
And the mate.
And the mate.
And the mate too. With the other hand.
Yes, but never forget the masita.
I remember in December, when was the approaching of Saturn and Jupiter, I went with my brother almost 10 kilometers from here, and we grabbed the equipment in the entrance of a farm. Obviously, we not pass through, and it was in the afternoon. So people passing by, and we have our telescope right there, and some curious farmers came to see what we are doing. So because of course maybe they think they are maybe they have problems, or maybe they want to show something. So we invited to if they can be with us, but they don't have any problems. So we
I can
continue.
imagine the accent of that people. Que está mirando, está mirando. Oh no,
Yeah.
yes,
It must like that, yes.
Yeah.
But that's the thing. That's the key thing. I mean, is have a friendly demeanor. Then people will generally be understand. I mean, I think people will be very understanding. But you can't be paranoid or you can't be aggressive.
No.
Then you're fine. I'm sure.
Well,
Yeah.
a couple of days ago, I was talking with Nico and some friends to maybe do some encounter, to do some deep sky, or maybe a few fields pictures, maybe in a month. And I was wondering what we can do to get prepared from any caution. So a policeman called me that day and asked me some cost of toners and cartridges and everything, and I asked him what we have to do to be careful when we go outside, and he said, well, you have to call us to know that you are in there, so the people see you. When call us, we tell them
they have an
that it's
answer.
okay. Exactly. And
Yes.
obviously, if a patrolling policeman passing by, they don't bother us. So that gave us some.
If you talk, you don't have any problem.
Exactly.
Yeah.
Yes,
maybe
they
if you
know
are a
that
foreign,
you are in this place, and they know that you're yes, and it's nice when the people from the police came to watch. Normally, for example, many times say, come here to see the small Saturn. Normally,
You invite them.
Yes.
Of course, it's strange to everyone that what are you doing in the middle of the night, in the cold nights, with this thing that you have with relays?
Without a light.
Yes, but it's so interesting, something that Maxi, that about how the expression for the people that never watch something by all through the telescope, and I really enjoy the face, the reactions. You know that in our store that we had in the Plaza San Martin area, we have a big area for to put telescope. Maybe at 6 p.m. when all people go into the metro to the subway, in our place the people stop to try the telescopes, and we of course we put the telescope at this hour to show to the people, and we make a huge star party in the middle of the city. Especially when we had a moon, the moon is the best thing to show, but Jupiter and
also when people see the moon for the first time through a telescope, they blow your mind, because they never see that magnification, that kind of craters, and
it's the best thing to show.
It's a feast for the eyes. It's a feast for the eyes, because there's just so much structure to look at. That's the thing. It's not, you're not just looking at one thing. You see it all, and you see a lot of things. Your brain says, "Ooh, I see all these ridges. I see craters. I see bright and dark spots. I see the terminator. I see the edge of the moon." There's so many really neat. And actually, if you look, and you start to see more detail as you train your eye, you even on the edge of the moon, you see it's not flat. It's not round. You see it's actually, you see the ridges and stuff, and
irregular.
And I really love, along with Terminator or along the meridian, you have the you can see the peaks of that are showing on the new sunlight, right? The peaks start showing, from the craters and the mountains. Oh, I love that. It's so awesome.
Absolutely, Cameron. It is something that, for example, when you show the moon in maybe where the moon is a little bigger than the field of your eyepiece, to show to the people that is amazing, because you feel like a 4K or 8K resolution the moon. Because yes, and for the people that never say that is like if you are going approach to the moon, flying and going to land to make a moon landing to the moon, it's amazing, and it's something that you can take an expression for the people. Well, kids are amazing, totally. But I remember that we in each promotion of telescope that we made, it was mostly in the end of the 90s. We continued making this to the 2010. Something sad that I can say is why we stopped to make this, because the safety, the security in Argentina changed a little in the last 10 years for words. We, of course, when you put telescope in the street, you needed to make a little care of this, but in the last 10 years was only we make the typical star party in close places. It's like Maxi said, rural areas are safer, like metropolitan areas, of course. But normally we organize star parties where we don't have that problems. When we make the star party in San Rafael Mendoza, of course, that is really a safe place, but it's a hotel, a big hotel with a big area, and they have a 7 kilometers entrance. They have a lights that they turn off for us. Great. And yes, really, you have a really dark sky in this place. But each time is worth not only the place where you have you is not able to have a dark sky, if not to the new problem is the get a safest place. Yes. We made star parties at only 70 kilometers or 50 kilometers from Buenos Aires, that today, 20 years ago, we found it safe, this place safe, and today we are not sure that still be a safe place. It's something that we are going to make star parties in the more rural or areas or mountains, because you need another thing today that is not a dark sky, if not a safe place.
Yeah,
for sure.
Yeah, that's true. It's a natural. I've seen also with that same thing happens with little lake communities or like smaller towns that are nearby.
Absolutely.
The younger kids want to party, they go out there and they cause problems, and and they're usually not very cooperative. So
yes,
they want to have fun, and and they don't care about anyone, and
yes.
So it's
hey guys, sorry to interrupt.
Yeah.
I will go to sleep because I have to work in
Nicolas.
4 hours.
Yeah,
me too.
Actually,
tomorrow.
Actually, that's fair. We should probably give Scott. Scott has been doing a marathon here. We should probably let him go as well.
Yes.
We've really had a good time. Thank you so much, Scott. I mean,
That's good.
Yeah, it was
great
night. It's awesome. Thanks, Nico. Yeah.
You really make me laugh today, Scott, with the photo on the flyer. I crashed and I cried.
It was a nice
laughing.
picture. It was a nice picture.
I was not expecting that picture is one in my wedding night, and I was
I need a new picture.
I thought that was a guy from Oregon, Nico, because you know the bear, yes, the timber in your hand. Yeah.
It was very funny. Okay, guys. Good night, everyone.
Good night.
Have a good one, everybody.
Thanks.
Thank you to the audience. Thank you very much. Remember, tomorrow we have Linda and Tom Spilker, or Tom and Linda Spilker from the Jet Propulsion Laboratory. Tom has now gone on to work in other aerospace endeavors, including, I think one of them is building a space station. So, but Linda Spilker has gone from being an intern at JPL while she was finishing up university to she got put on right onto the Voyager mission, and so she went through that whole experience, and then went on to be one of the principal scientists of the Cassini space mission, mission to Saturn. And now that has come to a close, she's now back at Voyager, which is still working, still sending information, still doing science. So just a remarkable mission the Voyagers have been. And now I think in their 44th year, we're still operating them. Linda Spilker and her, we'll talk about the whole Voyager program and her place within it, as well as Tom Spilker, who had many great experiences with the early program of Voyager. You guys have a great night, and keep looking up.
Right.
All right.
Good night,
everyone. Good night, everyone.
Yeah, I'll say good night at the end.